Hello everyone, welcome to this beginner friendly RAG course where we'll start from scratch and at the end you will know anything and everything which is related to RAG. For this course, it is going to be a series of videos where I'll be explaining what are all the optimization which can be done for each step of RAG. It's not like okay, we'll get the query, we'll compute the relevant document similarity and then those documents will be used for generation. That is the basic RAG, but that is not the aim of this course. In this course, we'll be seeing what are the optimizations which you can do in each step. And also, there will be some steps which we usually don't see. For example, the steps like query translation or query construction are not some common steps which we usually see. So, in this video, we'll start with what are all the things you will see in this course, and this video will be about the introduction of RAG. We'll see about an overview on every components, and this video will also consist about the information on what are all the things you can expect from this course. Now let's start with the explanation of this image. So usually when you give a question, what happens is once you give a question, you will get the relevant document from the vector store, and those documents will be combined together, which will be given to your LLM, which will give an answer. That is usual. But here there are some advanced steps. For example, once you give a question, you can do a step called query translation, in which the given input question will be translated into another form which will be more efficient than using the question itself. And there are some other methods, like for example, if you have multiple data sources, it is possible that you can do a routing, which is dynamic routing, where you can make your LLM to choose from which data source it wants to consider the document to retrieve from. That is highly possible here. And once that is done, what kind of query do you want to use? So are you gonna use a conventional method where given a query will compute the embedding and from vector store you'll get the answer? That is also there. Or you can use GraphDBs like Neo4j and many more, where you should use cipher query language for that. So you need to convert your text into a cipher query language to send it to VectorDB, which is GraphDB here. Or else the normal relational databases where you need to convert it into SQL. So for example would be your PG vector and all. Okay, PG vector or your conventional SQLs also will come into the relational database category. So here are your databases. Okay, now you have your query, and through your databases you are getting your document. Okay, so to create this databases also, there are some things which you need to do. Usually we'll do chunking, right? So there are some methods for you to chunk. So chunking, and once that is done, you'll be computing embeddings, and all those embeddings will be indexed and stored into vector store, and this step is known as index. So once this is also done, your retrieved documents will be formatted in a different way. Okay, so there are ranking, refinement, active retrieval. There are many other methods. We'll see each of these in detail, okay, in the upcoming videos. So once that is done, your brain, which is your LLM, will try to answer your question with the help of this document, which you filtered out, and that is your generation part. Okay, so all of these will be explained in detail in this course. In this video, we are going to see about an introduction to the RAG pipeline. Now let's start with the introduction to RAG pipeline. And by the way guys, don't worry, this is a completely free course. The code will be open sourced, and since I'm going to use open source, it wouldn't involve OpenAI at any point in time, so that you will also be able to execute it in your local system, and there is no requirement for GPU for this specific course. Now let's jump into the first part, which is introduction to RAG. Before going into the course, a big shout out to the creator of these codes. He is also inspired from the course from which I learned, which is from LangGraph. So a huge shout out for Nisar Agaria and LangGraph. So now that the shoutout is also completed, I think we can start with the course. The first step would be for us to set up the environment variables and API key. So for this, you need to first create a .env file in which there are three main API keys for this whole course. The one thing would be getting your Langsmith API key and name it as Langchain API key, and then your Groq API key, and followed by that you would also require Tavily API key at the later half, where you will be building a lot of agents. Here you can see, right, these are some things which you will cover in this specific course. So those are some API keys I think you should make sure that you have. Just create a .env file and place all of your API keys in there. Here, first thing is we are setting the tracing to true so that each step of your pipeline is traced. Trace is nothing but logged. Okay, and then you are setting your endpoint, Langchain endpoint, to api.langsmith.com. The Langchain project is advanced RAG, and the Langchain API key is provided already along with the Groq API key as well. So first let's load the .env file by finding the .env file and then loading the same, and then we'll set up our environment variables. So here is a sample overview code of RAG. Okay, the first step would be to load the documents. Let's come to the import later. Okay, when we go through here, you'll automatically know your imports. Here we'll be using the first step to be loading documents, for which we are using web-based loader, where we are using this URL. We are loading this URL, which is about agents, and we are setting the beautiful soup keyword arguments by setting it with class to post content, post title, and post header alone. So I need only these three contents. I don't need any other. So that is what we are trying to provide there. And you are loading the documents by calling the loader.load function. Next, we need to split the documents. So this is nothing but your chunking step. Okay, the split step is also known as chunking. So in chunking, the first step, there are lots of ways. Again, we'll be talking about in detail on each of these steps, where what are the advancements you can do in the following videos. Or yeah, so for here you need to split the documents, for which we are using recursive character text splitter. The chunk size is 1000 and the chunk overlap is 200. So what it means? It means that given a text document, I'll be splitting every 1000 characters, and I'll retain 200 characters for each chunk. So again, if you find this confusing, don't worry. It will be something like this. The first one would be 0 to 1000. So the first one was 0 to 1000, right? The second one would be, if you guessed it, by 800 to 1800, then you are right. So it will be 800 to 1800. Similarly, you will retain for, the 200 characters will be retained. So why is this required? You see, with RAG, there is always this problem of losing context, and still you'll lose context, but this will help you to reduce the amount of error by having an overlap. So these two are hyperparameters which you need to experiment with. Here you have your splitter, text splitter, which is initialized already, and you're calling the split documents, which will take an iterable of document as parameter, which is nothing but a list of document. Okay, so a list of documents is already created by calling the loader.load function, which is your web-based loader. Okay, a loader which is used to load websites, basic. Okay, now you are splitting your documents, so your splits are ready, or your chunks, if you want to put that way. The next step would be to embed your documents. Okay, so for this, we are going to use Hugging Face BGA embeddings. Like I said, you do not require GPUs and all. We are going to use only your local CPU and Groq API key. Both are free to use, and yeah, that's why we are using BG small en, which is a very small model, and that is open source, available in Hugging Face. And here we are setting the device to CPU because I have GPU, but still I want to use CPU. And we are also setting the normalize embeddings set to true, so that embeddings are normalized once it is produced. And we are calling the Hugging Face BG embeddings class, where the model name is this one, BG small en, and model keyword arguments to set that yeah, I need to run my model in CPU, and the encoding keyword arguments are provided with normalize embedding set to true. Okay, so now your embeddings instance is ready. Okay, for this, now usually you will store your embeddings, because computing embeddings for n number of documents is not always easy. It is a time consuming process and it is a waste of resource. So what we'll do is we'll create a storage which is known as vector store, for which we are using FAIS. Okay, FAIS is from Facebook, and it is an amazing open source vector store. And here, to create a FAIS vector store, all you need to do is just call from documents, which will take two values. One is list of documents and what is the embeddings instance you are going to use. So here I've provided my documents. Along with that, I'm going to use Hugging Face BGE embeddings, which I'm providing here. Okay, so here usually what we'll do is we'll be using this vector store for our retrieval process, and this retrieval is known as dense retrieval. Okay, remember the name dense retrieval, because dense retrieval is the process of using embeddings to find the closest embeddings. So every sentences you are going to represent in the form of embeddings, so the closest embeddings will be retrieved. That is dense retrieval. And there is also other method known as sparse retrieval, for which you will use methods like BM25, and that will be more of conditional, if you want to put that way. Okay, so embeddings or context based. Okay, so that is this retrieval. Okay, now for our generation. Okay, so here we are using an RAG prompt from the Hugging Face LangChain Hub. Sorry, not Hugging Face Hub, LangChain Hub. Okay, so RAG prompt is nothing but a prompt which will have f strings in it. Okay, so for example, this will look like an RAG prompt. Okay, here answer the question using the given context. Okay, this is a sample prompt. I'm not saying this is the prompt which is used from the hub, but this is a sample prompt. Okay, so we'll be providing something like context is to context and question is to question. Okay, so this is a sample string which is easily formatted by using string.format function. Okay, so if I call dot format, I can easily call context equal to and provide a value for it, and question equal to and provide a value for it, and that will be applied here. Okay, so this is just to provide a single line input to the LLM, because once you retrieve, you will have n number of chunks, and we can't pass it as n number of chunks. We'll format it in such a way that it is a single prompt or single input. So this stage is known as prompting stage. Usually we don't consider it as prompting stage. It is a part of your generation. Okay, so here we are using this prompt, and for LLM we are using Groq, which is again an integration from LangChain. I'm a big fan of LangChain, so I'll completely use LangChain and LangGraph for this course. Okay, but yeah, if you want to use Llama Index, it is also a very good framework. You are more than welcome to use it. Okay, so here I'm using Groq, in which I'm providing the model name to be Llama 3 8 billion, and the context length is 8192. The temperature is 0, which will control the generation of output. Okay, 0 will be the most controlled and 1 will be the least controlled. Okay, so that is your LLM instance being created. It's not your final LLM. Okay, here there is a function for formatting the documents, because like I said, you'll have 3-4 documents. You need to combine those as a single string. Okay, so that will happen with the help of this function. Now you have all the components which is required. Okay, you have your splitter, you have your loader, so you are ready with your vector store. Okay, all it is required is a pipeline through which you can ask a question and you need an answer. So for that you can use a chaining method, or that is what is called as it is chain. Okay, here you'll provide your context with the retriever output. Okay, where once that is done, you'll format the output with the help of format docs. Okay, you will send it through your retriever, and the retriever output will be formatted with the format docs. Okay, question is done with runnable pass. Runnable pass through is nothing but it will pass from one stage to another. and these two are provided to prompt, which will be formatted like I said before, and will be provided to LM for output. Okay, and then we'll provide a string output parser where this will do nothing initially, but you can do a lot of other output parsing as well. For example, here it will try to avoid some if there is something like end of text and all, those will be avoided. Okay, but there are some key output parsers like JSON output parser and all, which you can use. Okay, this is output parsing from which you'll get your output. Okay, all you need to do is just call the invo function and for this chain, and you can provide a question. For example, here I asked what is task decomposition, and it gave me an answer. Okay, so yeah, now coming on to the next step. Okay, the next step is indexing. So what is indexing? Okay, given a question, you'll compute a embeddings and you will compare with all the vectors which are stored with their respective indexes, which is created by again documents which are chunked, and embeddings are computed and stored in the vector store. Okay, so let's say you have a document which is red. Okay, so there are not a document, let's say your question is red. Okay, the orange, green, blue are the documents which you already put here, or here it is. Okay, it is red, blue, green, so orange is your question. Okay, the closest document would be red document. Okay, so you'll get the index of that document, and that document is provided as relevant document. This step is retrieval. Okay, but you are providing these documents to the vector store, right? This step is known as indexing. Okay, so for this, what you need, the first step would be we'll have two documents. Okay, why this is required, I'll say later. The same thing. Okay, you'll indexing. For indexing, first you need to load your documents. Okay, so again I'm using the web-based loader, splitting the document, and here I'm gonna initialize with my Hugging Face embedding. Okay, so here if I call the question and document, if I'm gonna embed those, right, it will give me an embedding of 384 dimensions. Okay, what happens essentially in this retrieval process, that we are going to see now. You see, retrieval is nothing but a cosine similarity. Okay, so to compute cosine similarity, all you need to do is, there are some already existing cosine similarity default function, but if you are going to write it by your own, first you need to do, what you need to do is, let's say you have a document and a question. For example, here the document is, what kind of pets do I like? My favorite pet is a cat. The question is, what is the favorite pet? And the answer, or the document which was available, is cat. Okay, here what happens is, you'll first compute the dot product of one vector to another. Okay, so this is like, even in attention it will work with dot product. Okay, so you'll compute the dot product of your question to your document. Okay, so this will give an output. Okay, keep that output as, and what you need to do is, next you need to normalize your vector 1 and vector 2, which is nothing but your query and your document. Okay, so once those are done, what you need to do is, your dot product needs to be divided by the multiplication of normalized vector 1 and normalized vector, and the final score here is 90%. Okay, so the input and input query and the document is 90% similar to each other, or 90% close. Okay, the cosine similarity is just a score which will show how much is a document affinity towards a question. Okay, so yeah, this is basically the vector store retrieval process at the behind. Okay, so again here you are seeing the vector store created, and the retriever, if you see the instance, it will have face and Hugging Face BG embeddings. Okay, so it means the vector store is face. Here you can see it is a retriever. Okay, the vector store is face, and the embeddings the vector store is using is Hugging Face BG embeddings. Okay, if you are just gonna retrieve, okay, for example here I called it as a chain. Okay, the chain was called, but if you want to see the retrieval by yourself, all you need to do is just call the get relevant documents function. Okay, already we have the documents, right? We have the web-based loaded documents here. So all we need to do is, we need to call the get relevant documents function, which will take callbacks, tags, metadata. There are metadata retrieval which is possible, and run name. Okay, so if you are going to do a batch, you can do batch or you can just do get relevant documents also. Okay. Um, if I call this, I'm getting 4 documents. Okay. What are all the 4 documents? You'll be able to see it. Okay. These are the 4 documents which are related to task decomposition. Okay. Instead of a huge website, now I have 4 to 5 lines from which I can answer the question. Okay. So that is the key point of RAG, to localize the context from which you can answer the question. This is just a workaround where there is a situation that you can't answer with the help of your LLM because it is out of the context length of the LLM, and you are just working around with an embedding model which will provide you the localized context from which you can answer. Okay, now here you have your context question which is prompted together as a prompt, which we already saw, right? And that will be provided as your input to your LLM, and finally it will be parsed and provided as output. Okay, so here is a template like I said. Okay, the context and question are just values, okay, or placeholders or variables to which you can fill. Okay, so chat prompt template or prompt template, these are nothing. Okay, if I'm gonna format this like this, template dot format, and context is the variable, right? So context equal to something and question equal to something. If I give this, okay, this is as same as this chat prompt template. Okay, these are just fancy names, but very easy even without those. Okay, but since we are using an orchestration framework, those are written in such a way that it will be working smooth by hand in hand together. Okay, all you need to do is just provide the template, and you can provide your variables as well here, and it will be able to answer. Okay, so here you are providing your LLM, which is again chat Groq. And if I make a chain with the prompt and LLM, because we already retrieved the documents, right? We retrieve 4 documents. We are just prompting those 4 documents which will be combined together here, and our question will be provided here, and it has finally provided an answer for task decomposition. Okay, and if you are going to create a chain, it is nothing but the whole pipeline will be combined together. Okay, so for which I'm providing a prompt already. Okay, the context will be obtained from the retriever. Here I'm not calling the format docs, you can call if you want. Okay, and format docs is nothing but to say like, okay, this is document 1, document 2, something like that. If you would just if you just don't want to combine all of those together like a sandwich, you can format those in a specific way, of however you want to, and that is your format docs function. Okay, those are provided to your chain. Okay, your question again is a runnable pass-through instance. These 2 are provided to your prompt hum rag, which is just again a prompt. Okay, and here you can see it will have 2 variables, context and question. Okay, here is the prompt. Here you can see it is like you are an assistant for question answering task. Use the following pieces of retrieved context. If you don't know the answer, just say that you don't know. Use 3 sentences maximum and keep the answers concise. Your question, here is your context, provide the answer. Okay, so that is your format prompt, and when I provided the question, it finally provided an answer. Okay, so yeah, that is RAG. All right, so I hope you will have a good idea about RAG by now. In the next video, we'll be seeing about the next concept, which is query transformation, a step which is used to change the questions in a different manner so that your output is enhanced. There are lots of methods like multi-query, RAG fusion, decomposition, step back, hide, and we'll be seeing all of those in detail in the next video. I'll see you all in the next video. Until then, if you haven't hit the subscribe button, please hit the subscribe button, hit the bell icon, share it with your friends who all needs to start with RAG. This would be a good place for them to start with. I'll see you all in the next video. Until then, happy learning. Hello everyone. Welcome to the second video on the complete advanced RAG course. In this video, we are going to see how you can transform your query by using set of approaches so that your retrieval process is highly enhanced, improving your accuracy. Before moving deep into the video, if you haven't watched the previous video, I highly recommend you to watch the video to have an idea about the course as well as the RAG pipeline as a whole. I hope you all have watched by now. So now let's start with query transformation. Stay till the end and you be able to change your query however you want after this video. So first, as the name suggests, query translation or query transformation are just a set of approaches which can be focused on rewriting or modifying your questions for an enhanced retrieval process. Here again we are going to set the same environment variables, so those are the same. And the first thing which you can do is multi-query. Okay, so what is multi-query? Once you provide your question, what you need to do is you will provide it to your LLM, which will provide multiple forms of the same question. So for example, if I'm asking who invented gravity, okay, so there is only one answer: Isaac Newton. Okay, at least he was the one who coined the term. All right, but there are some other ways to ask it. Is Isaac Newton the first one who coined the gravity, or no, however you want to put that way. Okay, so if there are possibilities for LLMs to compute different questions, we are going to do that. So why is that? You see, the embeddings are computed for the meaning of sentence. Okay, but the words also play a role. All right, so if you're going to compute different questions which would slightly differ in meaning because the words used are different but are similar, there is a high possibility that you will find your document rather than relying on one question. Okay, so if I ask what is the working of LLMs, I can also ask it as how does large language model works. So I can ask about what is the mechanism which large language model uses to be this accurate. All are going to be focused on one thing, which is LLMs working. Okay, but the possibility of you finding an answer with the direct question of what is the working of LLM is lesser than you computing 3 questions out of it and finding 3 relevant documents for those 3 questions, and based on those providing an answer for the given question. Okay, that is the idea of multi-query. Okay, so for all of these, the documents are there. You can just click this document and you will get a detailed explanation on your multi-query retriever from LangChain document itself. Okay, but we are not interested in the explanation of the retriever. We are more interested on the process and how you can use that. Okay, so I'm not going to explain the same things which I have already explained before. Okay, so similarly you are indexing, which means your documents are loaded here, you are chunking it. Okay, your chunks are ready, you're computing your embeddings for those, storing it in the file vector store, and the vector store is created as retriever. Okay, now how does this multi-query happen? Okay, you see, it will be very funny that this is an advanced RAG course. Okay, but you'll rarely do a lot of coding to achieve what you want to do. It will be more prompting. Okay, that is how LLMs are, right? Okay, so here you are going to create a prompt template. That is the idea. Okay, so previously we saw, right, we'll be creating chains. Okay, in that chain you'll had a first step where instead of one question you will pass 3 questions. Okay, to compute those 3 questions you will add a component in your chain. Okay, that is the key idea here. Here the template for generating the multiple question is that you are an AI language model assistant. Your task is to generate 5 different versions of the given user question to retrieve relevant documents from the vector database by generating multiple perspectives. Please highlight this word in your mind, multiple perspective, because see, like I said, the user will ask in one perspective. Okay, but necessarily the answer might not be in that perspective alone. Okay, there are multiple perspectives which could be answered with that question itself. Okay, so all we are trying to ask is the model to generate questions in multiple perspectives, because the goal is to help the user overcome some of the limitations of the distance based similarity search. Like I said, it is about one sentence close to another sentence. Okay, rather than one sentence, if you have 5 sentences, your probability of finding your answer is higher. Okay, so that is the idea of multi-query prompting. By the way guys, I'm trying to break it down very simple so that everyone will be able to understand. If you are like this video, please hit the like button, share it with your friends. If you haven't subscribed to the channel, please hit the subscribe button, hit the bell icon, because this is a course anyone can learn with ease. That is how I'm trying to teach it. So yeah, I hope you will all be finding this very useful. Okay, now to generate queries itself, you'll have a chain. Okay, here you have your prompt perspective, which is just a prompt template. Okay, so that is provided to your LLM, which is by default it will be mixture. Okay, if I provide something, it will be in another model. By default it is mixture. Okay, your output is parsed, and what we are doing is we have already said here. Yeah, you can see this is why I didn't read that before. Provide these alternative questions separated by new lines. Make important for this point, because you'll have number of questions generated out of output, but you need to provide those questions as separate inputs. Okay, you need to separate those. So we are specifically saying that you need to separate your output with the help of new lines. All right, so the original question is already provided here. All right, so that is your generation part. So if I ask what is task decomposition, here you can see, can you explain the concept of task decomposition and its significance? See, if I ask about task decomposition, even I can answer about, its significance, which is a part of explaining about task decomposition. One different perspective. And how does task decomposition work in the context of problem solving? How does it solve my problem? Okay. Third one, what are the steps involved in breaking down a complex task through task decomposition? Okay, breaking down a complex task. So you are adding some more context, which will give a different perspective, so that you'll be able to retrieve more relevant documents rather than with that one simple question, which could be literally in. Okay. So yeah, you have 5 questions, but what is the next step? You can't just pass all of those, right? So what we'll do is you'll get a unique union of the retrieved documents, because here you can see the image. Okay, the questions might be different, but the documents will be provided together for LLMs. Okay, if you are going to provide the same document again and again, it is going to be either giving more importance to that documents, or another thing, it is obviously going to go out of context window, and it is going to waste your cost. Okay, so we'll take a list of unique documents. Okay, this is just like list of set, something like that, of those documents. Okay, so all you need to do is first, once you provide the question, we'll be generating number of queries, and we'll call the retriever.map function, which what it will do is it will first get the unique union. Okay, and this map function, what it will do is the retriever output will be mapped to there. Okay, all retriever outputs at every stages will be provided here. Okay, so you will provide your question here. Okay, and now if I see, there are 6 documents. If you remember from the previous video, we retrieved 4 documents. Okay, but here there is 6. Those 2 might not be needed. Okay, that is also an acceptable point. But yeah, LLMs are very good to answer the question even with some rubbish inside it. Okay, here you are making sure that your answer is found, so probably you might get a better answer in those 2 contexts. That is how good is this multi-query retriever. Okay, that is what is being helped in this multi-query retriever. Okay, so what then we'll do is we'll be providing those context, and the question will be provided. Okay, and yeah, finally you will provide your output, which is obtained here. Okay, so that is multi-query retrieval. There are some other steps as well. For example, once your multi-query retrieval is complete, instead of just doing combining together, stacking it with unique set of documents, there is a method known as RAG fusion. Okay, that is the thing which we are going to see. Again, what we are going to do is we are going to create multiple queries based on a single query. Okay, here again we are generating queries, but for combining documents, what we'll do is we'll be using a method known as reciprocal rank fusion. Okay, if you are going to go through this code, it will be very tough to understand. Okay, it will be a very tough one to understand. I'm not even going to teach the formula, but I'm going to teach how it works. Okay, so here would be a sample explanation to how the reciprocal rank fusion works. I'll say the formula, okay, but I will not say why the formula, how it is used, that and all. Okay, now what we are going to do is let's consider a sample where the sample set is 4 documents. Okay, and you are going to compute 3 questions. Okay, the first let's say your first question was C. All right, you started with the C question, and your LLM helped you compute with B and A. Okay, the C question said the order of relevance is 4312. Okay, the B question said it is 3124, and A document said it is 1432. That looks good. Okay, so now three documents are saying three different orders. Okay, three questions came from a single question, which was question C. Okay, here itself you are seeing, right? It could have been 4312 directly, and we would have said the first document is the most relevant document, but it is not the case here. Okay, because you can see according to the B question, it is the least relevant. Okay, so I think it should be reordered, which we'll see now. Okay, what happens is the rank of each document will be calculated. Okay, for document 1, question A says it is 1, question B says it is 2, question C says it is 3. For document 2, it says question A says it's 4, B says it's 3, C says it's 4. Wow, I don't think any of the question liked document 2, but for document 3 it have been good. 312 and 241 for document 4. Now if I ask which is the most relevant document, you would say okay, 312 123, probably document 1 or document 3, and then document 4, and then document 2. How are you saying this? Because now okay, on an average, if you see document 1 is good, and then document 3 is good if the total value is computed, and then the document 4 is good. Okay, this is one way. Okay, that is probably a good way for you to try. But there is a calculation for reciprocal rank fusion where what you will do is you will take an arbitrary value, okay, for k, which is 60 here, and what you'll do is you will divide 1 by k plus the rank. Okay, so what did question A say? It is 1, 2, 3. You will compute all those values and you will compute the you will compute all of those together. So that is why it is reciprocal rank fusion. You are getting a reciprocal here and you are fusing all of those values. Okay, so it is 0.0487 for document 1, 0.0469 for document 2, 487 same as we expected. Okay, for document 3, and for document 4 it is 0.484, very close. Okay, so the order would be document 1 or document 3, and then document 4, and then document 2. If I had probably gone by, there are two disadvantages we came over right now. First thing, if I had used a single question, which is probably question C, I would have ended up with 4 as my most relevant document. Okay, so it is wrong. So probably that is one issue. The second issue is if I had just combined all of those together, I could have combined 4 at the top. That is highly possible. Okay, those are all avoided here. So that is reciprocal rank fusion, which is computed here, and that is just like I said, it is just a process of combination. There we just took a union and combined all of those together like a sandwich, but here we are doing it with some mathematical logic behind. Okay, and that is what is giving an output here. The next type is decomposition. Let me ask you this question. If I give you a tough problem, what you will do? Okay, you're giving me a tough problem. Yes, you can give me, that is fine. What I'm gonna do is I'm gonna make it step by step. As I'm gonna make a step-by-step question to myself, and I'm gonna answer all of those questions. So for example, if I ask what is 3 power 2 plus 2 power 5 multiplied together with 10. Okay, so what you will do? Okay, first let me compute 3 power 2, which is 9, and then 2 power 5, 2, 4, 8, 16, 32. Okay, 32. 32 into, let's say 3 power 2 is 10. Okay, I'm bored. Okay, 3 power 2 is 10 and 2 power 5 is 32, so it is 320. And now I have computed all of those. Now what I need to do is I'm gonna need to multiply it by 10. Okay, it's 320. Then you are answering the question in a step by step, right? You are breaking down your question into a set of sub questions. That is decomp. Okay, so the decomposition is nothing but generating multiple sub questions which is relevant to an input question. So okay, that is what we are providing as task prompt as well to the LLM. Okay, the goal is to break down the input into a set of sub problems or sub questions that can be answered in isolation. Key, very key. Okay, there should be an answer for that specific step. Okay, and I'm asking 3 queries here. You can ask any number of queries. Okay, 3 is an average, choice. If I ask what are the main components of an LLM powered autonomous system, so it is asking, okay, what are the main components, and then role of a natural language understanding in LLM autonomous agents. How does natural language generation contribute to autonomous agents? So it is seeing some things. Okay, probably this is not the best example to get out with decomposition, but yeah, it is a good thing when I say tasks like these. Okay, so if I asked something like I need you to make a context. Okay, there is a context, I need you to rephrase the context in some other language. Let's say there is a context in Tamil. Okay, and I need to rephrase the context in Tamil itself. Okay, but there is a specific format. So what the LLM will do is, okay, first, do I need to, convert it to translation? So I'll translate it. So what are the things which are required for my, rephrasing? So let's say I'm asking about, my YouTube channel itself. Okay, I'm gonna rephrase, right? So which means I'll have some questions, okay, for which once I get my answer, I can easily rephrase, right? So that will happen easily with decomposition. Okay, so that is the decomposition step. But with decomposition, like I said, it is a step-by-step process. Okay, so once you get your one document, your LLM will answer that, and that will be combined with your next document, will be provided to the LLM, and that is a recursive process of answering, right? So for that, here is a prompt. Okay, here is the question you need to answer. So that is your current question. Okay, this is like your timestamps. Okay, this is timestamp T. Here is any available background question plus answer pairs. Okay, QA pairs is nothing but your past question and answer pairs. You can say it as your context history or T-1 to T-1 till your 0th position. Okay, that is your context history. Okay, now you are saying, okay, this is your additional context for this question. Okay, so if you don't find your answer in this context, you are having an additional context here because this question is relevant to this context, right? So that is your additional context provided. So based on this context, your background question and answer this question. Again, we are seeing about the question and we are asking it to answer. How good is this? I think whoever came up with this idea, kudos to them. To solve a complex task, it's not always that your LLM needs to do it in one step. It can do with multiple steps, and big on them to create this simple prompt which will do wonders with complex tasks. Okay, so yeah, so what we are doing is here for the RAG chain, here we are providing context and question. Okay, so the context will be the question will be obtained and will be passed to the retriever, and that will be a context. Okay, again your question are obtained, and QA parse is just a history which we are maintaining. Okay, this will be provided to your decomposition prompt, and then is provided to LLM, and the output is parsed. Okay, so here we'll be doing this for n questions. Okay, very important, n questions. You are not doing it for one question. This is a loop. Okay, and finally after n questions is completed, you will get an answer. Okay, you got your answer. It's not just you need to answer it recursively. You can also answer it individually. Okay, so for example, you'll go to each sub question, your answers are obtained, and based on those answer we can ask it to generate an output. That is also possible. Okay, here you can see the answers are obtained and those answers are combined together, and then that is provided to your LM. This is nothing but a mixture of agent. Okay, so we are seeing about mixture of agent, which is probably a trending concept right now. This is nothing like this, like this is just the same. Instead of thinking as 3 relevant documents, just consider that there are 3 agents which gave 3 different outputs, and that is provided to a final agent. That is mixture of agents. This is nothing but your decomposition here as well. Okay, and then there is like another type which is step back. Okay, for example, here is a question. Could the members of the police perform lawful arrests? Yes, probably. Okay. But to find a context, relevant to this, I need to find a context which is relevant about, police being allowed to, make lawful arrest. That is harder. No. If I want to ask that, okay, what does the member of police do? There is a high chance I'll find an answer. I'm not saying you'll find a correct answer, but rather than saying I'm not able to find a relevant context, you'll be able to find, a context which could be, relevant at the farthest end. This situation, this is used to, solve the situations where a direct question might not find an answer, but if you take a step back, if you make it more abstract, you'll be able to find an answer. That is what is given here. Okay, that is a step back question. Normally a question is there. If you are going to sub question, it is like breaking down. Okay, so it will be like more definitive. Okay, but if you're going to abstract it a lot, it is step back question. Both are good in their own ways. Okay, so here you are providing an example input prompt from messages. Okay, so human messages are here, AI messages are here. But here we are going to use a different prompt template. This is few shot chat message prompt template. What is few shot? You see, if you give no example and ask the LLM to give an output for a given input, it is zero shot. If it is not trained on such a data before, if it is trained on such a data, it is one shot. But if you are seeing, okay, it is out of its training context. Based on these two examples, now try to generate a question which is a step back for a question which the human provides. That is few shot. So for that you have the prompt template, few shot chat message prompt template. Okay, now we are saying, okay, you are an expert at world knowledge. The task is to step back and paraphrase a question with a more generic step back question which is easier to answer. Okay, so the prompt is already provided here. And the question, once you ask, for example, what is task decomposition for LLM agent? It is asking, okay, how is a large language model's agent's task broken? Okay, what are the steps involved in completing a task for large language modeling? If I'm not able to find task decomposition, I'm sure I'll have an answer for this. Okay, we know task decomposition is a step. Okay, like we are just going with the same example since that will help you to understand in the course. But imagine this, if I'm searching over internet and I'm not able to find relevant to task decomposition, surely I'm going to find with these answers, these questions, right? That is why sometimes it is used to use task decomposition because step back, because it is not always you'll get a simple question or a simple task. You will get a complex question or a complex task. If it is a task, you can handle with task decomposition. If it is just a single question, even it is very complex, uh, there is a very less chance you will find a context relevant to that. Then you can use step back. Okay, so here you can see your response and we are just saying just a prompt. Okay, nothing very advanced if you want to put that way. And we are just providing our context as well. Okay, this is the normal context, this is a step back context. Step back prompt, step back question would have got a context, and the normal question itself would have got a context. We'll be sandwiching both of those together. Okay, and your question is also provided and the answer is obtained. Okay, so that is here. The another thing is, see, these are all the first things like RAG fusion, multi-query retriever are to ensure that you will get a correct answer, higher chance of correct answer. But the step back or task decomposition are to ensure that you have an answer. Okay, at least a partial answer out of it. Okay, rather than saying I don't have a context or something like that. To answer it, have a partial answer. You have those two. Let's say you don't even have a answer in it. Okay, but still you want to answer. Hide is, whenever I think of hide, I actually get a lot of laugh out of it actually. Okay, the idea is that you will write a context by yourself, okay, which is relevant to the context, the question, and from that context itself you will get an answer. Very funny, right? No, this is to ensure that at least I can see these are all steps to ensure that you at least have one answer. But height is not something which I like a lot. Okay, because as the name suggests, it is hypothetical document embedding. You'll generate a hypothetical document. I'm not a big fan of it, but yeah, you can do that. Okay, so that will also provide an answer. Okay, but your LLM should know something like related to that. If I ask about who won the T20 World Cup, it is not going to know an answer. It will say some random stuff, right? So yeah, um we saw some methods which will be able to handle some of your problems. For example, if you have a very complex task, use task decomposition. A very complex question, use step back prompting. If you're not sure you'll be getting your answer in one question, use multi-query retriever. Make sure that you have RAG fusion so that all of those contexts are efficiently used together. Yeah, this is basically the summary of this video, right? So yeah guys, I hope you all like this video. If you all like this video, please hit the like button, share it with your friends. If you haven't subscribed to the channel, please hit the subscribe button, hit the bell icon. I'll see you all in the next video. Until then, happy learning. Hello everyone. Welcome to the third video on the complete advanced RAG course. In the previous video, we saw how you can transform your query in different methods so that you'll be making sure that you have an answer, which is a very good thing because it is not always that you will get an answer with the help of RAG. The previous step was to increase the chances of getting an answer, and now we are gonna route it to different data sources. So routing, this is not a new word for us. Routing is a word which is usually commonly used at a lot of places, but here it is gonna mean that your LLM will be choosing which path I'm gonna take. I'm gonna take either vector store or database, like conventional database, which I'm gonna choose, something like that. Okay, why is it important? Let me give you an example right now. Okay, so let's say you are working for a financial use case. All right, it is like a financial chatbot for your company, and it is mainly to help beginners. Okay, a beginner needs to know about your company financials, and to know about financials, it is very important that it should be able to query over databases. Okay, but if it is like I'm asking, let's say a doubt about the company itself, all right, because he's like marketing department person, he's asking the bot about the company itself. It should go to the vector store because it is like a text data, but I don't know which to query to, right? So there will be using an our LLM to choose which kind of a database I'm gonna go with. Okay, so that is routing. Okay, so there is two types of routing. Again, you'll set the environment variables. I think by now you'll know that. Okay, routing is nothing but a classification. Okay, so here let's say for example you have a GraphDB and your vector store. Okay, so LLM, what it will do is it will give a function call. Just okay, should I call the function vector store or should I call the data GraphDB? That function response will be provided from the LLM. That's all. Okay, so to know more about this, again the document is provided, you can refer there. Okay, here we are first creating a data model. Data model is nothing but for example, a data class or data model, both are same, which will have a list of data parameters, okay, or parameters, which will have some values for it, a type of value expectation for it even. Okay, so for example, here the data source is for which document should I go with. Okay, so for example, if I'm having an error, okay, should I route it to my Python documentation or JavaScript documentation or Golang documentation? This is the literal. Okay, these are the value possible. Okay, the field is description. Okay, the field description is that given a user question, choose which data source would be the most relevant. That is the description of this parameter, which is data source. Okay, so here you're calling your LLM, which is chatgroq, and here good on LangChain that they enable structured output generation from LLMs. Okay, so when you call LLM with structured output generation, you need to provide your data class, what kind of an output you are expecting, because here I'm expecting what data source should I use. Should I use Python documents or JavaScript documents or Golang documents? Okay, so that will be generated from output. So we are providing a prompt which says, okay, you are an expert in routing a user question to the appropriate data source. Based on the programming language, the question is referring to route it to the relevant data. So now you will wonder, okay, how it will know I should call Python docs. That is why we provide it as literal. Okay, this is like, the sample universal set of values which is possible for a given parameter which is to be generated. For example, the data sources are Python docs, JS docs, and Golang docs, something like that. Okay, so for example, what fruit should I eat today? Okay, whatever fruits I'll eat, all we will provide as list. Okay, out of that list, one fruit will be chosen. Okay, that is routing. Okay, now your router is defined with this chain. Okay, the prompt is provided and to the structured LLM. Here you can see the function calling. Okay, so the schema will be provided. The schema will be provided in an OpenAI function. This is nothing but like, it will be like a JSON explanation. That's all. Your question is provided to the LLM along with the schema, which will provide a data source as a JSON string will be passed by the structured output parser by using the Pydantic object you created already, which is the data class. Okay, and it will say, okay, data source is vector store. Okay, now when I ask the question, why does the following code does not work? Now I need documentation. Okay, that is the idea. From langchain.core.prompts, import chat prompt template, prompt chat.prompt template, and so on and so forth. Speak in language, so whatever language it is. Okay, prompt.invoke French. Okay, now I have provided some sentence. Okay, this is a Python document. Why it doesn't work? Because I have provided as language, but I haven't formatted it with French. Actually, this should work. I think they just gave it simple thing, because you're calling the invoke function here. The French will be replaced here. That's fine. Okay, but there is some error. So which document should I refer? The error is irrelevant here. Which document should I refer? I should refer Python documents. That is amazing, right? See, now let's say you have the same thing. Okay, you have developers in your organization, which is a multinational organization, where you have your own guidance policies for each language users, because security levels for each language is different. If I'm going to ask a question and ask if this code is safe or following the guidelines, now your LLM needs to check the appropriate documents of that specific language. For example, there will be some conventions to be followed for Python. Okay, it should check for Python documents, not the JavaScript documents. Okay, this in itself is a use case in industry by itself. Okay, guys, the best way to learn any concept is to relate it to a real world. Okay, which we are doing right now. Okay, now again, if you want to see how you need to use this for different things, you can again go through the documentation here. But to use this as routing, it's just a piece of cake. Okay, for example, if it is Python documents, you will return Python documents here. If it is JavaScript documents, go for JavaScript documents. And if it is nothing, which means it is Golang documents, or else means only Golang is possible, it is Golang documents. Okay, so if it is choosing Python documents, you can write your logic for Python documents here. Okay, this is nothing but classification. Routers are generally classification. Okay, if you see mixture of experts, right? Okay, this is not related to RAG, but mixture of expert also uses a router. That's why I'm saying this now. Mixture of expert uses a router, which is nothing but a classification. You have 4 experts, and that router, which is nothing but a linear layer, is going to choose which expert is suitable to solve this task. That's all. Okay, so that is routing to data source. Now we saw the logical routing. You wrote a logic here, it will happen. That's fine. What about semantic routing? Okay, let's say there is an LLM. Okay, it needs to answer for any type of question. It should take a role by itself. Okay, so for example, I'm making a AI teacher. Okay, if it is teaching physics, it should know that, okay, I'm a physics teacher, I'm going to teach physics, so I'm going to make myself appropriate for physics. So similarly for math. Okay, that is the use case here. Okay, so here what you're doing is we are computing the embeddings for those 2 prompts. for math and physics. For physics, we are saying you are a great physics professor, you are a very good mathematician, you are great at answering questions about physics in a concise and easy to understand manner. When you don't know the answer, admit that you don't know. You are so good and you are able to break down hard problems into their component parts and answer the component parts, then put them together to answer the broader question. Two different tasks. This is kind of, your task prompts, and you're going to choose which task prompt I'm going to use dynamically. That is your router's job. Okay. So what we are going to do is we are going to create a chain in which the query will be passed through this runnable lambda, which is just lambda function will be called. Okay. Um, the name is like runnable, but that is nothing. Pass through is nothing like pass. Okay. And runnable lambda is lambda function. So the lambda function will apply this query as input here. Okay, here you can see input of query that will be passed here. Okay, sorry. The query embedding will be calculated. So what you'll do is you'll compute a cosine similarity of query embedding to your prompt embeddings. Okay, these two prompts, which is closer. Okay, so if you are going to use math, we'll be just printing use math right now, and if it is using physics, we are going to use physics. Okay, but the thing which is important here is you can take this to next level. Okay, so for example, what is black hole? Okay, if I ask that, you are passing it to the LLM. Okay, now this prompt will be chosen. Okay, here you can see using physics. A black hole is a region, blah 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 blah. Okay, it will assume itself as a physics professor. So when you have different tasks to solve, okay, and you have a task description, but you don't know which task you are going to do at a timestamp, then you can use this specific routing point. Okay, semantic routing. Now we are not just going to see routing. Okay, we are going to see another type which is also probably routing. Okay, because once you route, okay, that's fine. Okay, routing is part. What if you want to route it to a GraphDB? For GraphDB, you can't provide a natural language query. Okay, so for that, what you'll do is you'll do a step known as query construction. You'll construct your query which is appropriate to your data source. Okay, so for example, you can structure your query with metadata filters. Okay, so for example, here I used my own YouTube video again. This is a video from my channel, which is of length 902. I think it's 902 seconds. If it is 902 minutes, I don't think any of you will view my channel. It is GraphRAG, the most advanced RAG, which was a video I uploaded recently. The thumbnail image is also there. These are like the metadata, but where will be useful? We'll see that later. Okay, now what if I want to search a tutorial appropriate to my choice? Okay, so I'm creating a tutorial search class, data class, in which it will have a number of values. All are mostly optional. Okay, what is the content I want to search? What should be the title, close to title? Do I have a filter like I need at least these much people to be watched? Because there is this thing with some people's like big YouTubers, they'll make very good content. Okay, or small YouTubers, they'll be very passionate enough to make very good content. Depends on people's views. Okay, so for that there is a filter here: min view, max view content, who earliest published date, latest published date, how much length, because people might not like very long, some people doesn't like very short. So for all of those filters are there. Now you have your data class ready with all the parameters, literally. Okay, so what you're going to do is you're going to provide your prompt saying that, okay, you are an expert in converting user questions into database queries. You have access to database of tutorial videos of a software library building LLM powered application. Given a question, return a database query optimized to retrieve the most relevant results. Okay, if there are acronyms or words you are not familiar with, do not try to rephrase, because if you rephrase, it will result in an error. That is the idea. Okay, because if you see, if you are constructing a query with SQL query, all right, or even if you're going for graph, the main thing is what is the value you're looking for. Okay, if it is, for example, content search, and I need scratch content, and the title should be RAG, so it is like RAG from scratch and all. Okay, but if you are going more detailed, that is where this will be useful. For example, here, by the way guys, the structured output is called here because we need an output which is structured, which will just give the parameter and their value, and the class should follow tutorial search, which we already created here. Okay, for example, when I ask videos on chat lang chain published in 2023, so it is saying content to search is about lang chain, the title is about chat, and the earliest published date is 1/1/2023, latest published date is 1/1/2024, because I asked videos on 2023. If I ask about 2024, it is not even considering the earliest published date. It is saying, okay, I need videos on 1/1/2024. Okay, if I say, okay, how to use multimodals in agent, only videos under 5 minutes. Okay, it is saying, okay, max length second 300, and the title to search is about multimodal models. Okay, now you can query your database easily, right? Once you construct this, it is very easy to query to databases with ease. Okay, because you can see, if you're making SQL, if you ask your LLM saying like, okay, this is the value, make a SQL query, it will make a SQL query. If this is the value, make a cipher query, it will make a cipher query. Self query retriever is what we did now. Okay, metadata retriever, your metadata is obtained, from which only you will make SQL query or cipher query. Okay, so yeah, that is how you will use multiple data sources or route to different data sources. So yeah guys, in this video we saw how you will route it to different data sources, how will you construct the query so that you will be able to use multiple data sources, because if I'm considering GraphDB, that is a different source, and vector store is a different. All right, so yeah, that is about this video. In the next video, what we are going to see is a very interesting concept, which is indexing. Okay, how will you index your documents into a vector store? That will be our next step, where we'll be seeing about lot of things like multi-representation indexing, callbird, which is a very important concept. Okay, so yeah, I hope you will all be very interested to see that video. So yeah guys, I hope you all like this video. If you all like this video, hit the like button, share it with your friends. If you haven't subscribed to the channel, please hit the subscribe button, hit the bell icon, and come and let me know your thoughts in the comment section on how much you have enjoyed the course till now. It's been 3 days. So yeah, I'll see you all in the next video. Until then, happy learning. Hello everyone, welcome to the fourth video on the advanced RAG course. Till now we have seen about how you will translate your query so that you will be making sure that you will get an answer, and you will have multiple data sources. So how will you appropriately choose your multiple data sources, and once you choose it, how will you appropriately make a call to that source? Okay, those are all fine. Okay, but more importantly, these are all happening at runtime. But before all of these, you need to make sure that your data source is ready, right? That is what we are going to see in this video, where making your data source being ready is the step in which we'll do, and the step is indexing. Okay, you'll index all the documents in a specific format. So we'll be more focused on vector store, but GraphDB is something which is coming up very highly recently. Probably I'll make a video on that at the later half, not in this specific stint of videos. I'll make a video on GraphDB. For example, Neo4j is a very good GraphDB. We'll try that. For relational DB, it is very easy. For example, you can see my chat with database video as a relational DB example. Okay, so that is normal DB construction, which we are not going to focus on. We'll be more focusing on how will you index your documents into vector stores. Okay, the first step I haven't covered a lot, so I'll cover it with this itself. Okay, which is chunking. Okay, chunking. So what is chunking all about? Okay, you see, for knowing about chunking, we need to see the limitation of LLMs. Nowadays, LLMs are having very good context length. Not while RAG came into the picture, by the way, but LLMs have been around for so long, and there is this one problem with LLMs, that it didn't have good context length at that time. Okay, it didn't have good context length, and nowadays it has a very good context length, but still, if it is in somewhere middle, all right. Because researchers have shown that if your context is at the top or at the bottom, the answer, the answer context is at the top or bottom, there is a higher chance, or the likelihood of finding the answer is higher than in the case when you're finding it in the middle. But you can't do anything. Your answer is at the middle, right? That is something which is problem now. Okay, but the previous problem was you weren't able to use the LLMs to its full potential because the only reason is it went out of its context length. Okay, now you get the problem idea, right? So they came up with an approach that, okay, what we'll do is we'll split the document. Okay, so once we split it, now it will fall under the context length. Okay, now I'll be able to use it. Also, that is one thing, and another thing is you will reduce a lot of cost. Okay, rather than using a complete document, you will reduce the cost to a lot of extent, and the time will also reduce. Okay, that is also there. There are lots of good things with RAG, but still, what if your chunk is not retrieved correctly? That is a problem which will be there. So that error is not something will be able to solve it a lot. But with GraphRAG, that is being solved a lot because the chunking itself is very different. But that will keep it in a separate video, okay? Because like I said already about GraphDB, right? Graph related concepts in AI is very advanced, and it will take a separate video for me to explain about that itself, okay? Because I have kept a limit of around 30 minutes max for a video, but it will take me 30 minutes to explain about the chunking concept which is going on behind in GraphRAG itself. So we'll keep that for a separate video, probably for GraphRAG itself or graph related AI itself. If you want, let me know. I'll make a series on that. Okay, but here we are more focused on the conventional chunking optimization methods. Okay, what are the ways you can chunk? The first chunk, which is probably the worst way, which is character. Okay, for characters, I'll split it. That's all. Or else you can split it by sections. Okay, in HTML there is sections, in documents there is paragraphs. You can split it in that way. Okay, or if it is you're thinking, okay, if I split like that, I'm going to lose context, the meaning might not be complete, and you're concerned about a lot of things, which is very fair. Okay, for that there is semantic splitter as well. Okay, you can chunk it semantically, but the problem would be that you'll be running a model to chunk rather than just a Python code, which means it will take a lot of time. Okay, if you are having a use case where the chunking is not happening at runtime and you are doing it prior at the back end, and only the questions happen at runtime, you can prefer semantic chunking. That is a very good option. Okay, and finally you have delimiters as well. For example, you have TSV, you can split it like that. Okay, so these are the chunkings we can do. Okay, that's all. You'll just split it. So the chunk size will be provided, and to that length it will be split. Okay, to at least retain some amount of context, we'll be providing a parameters known as overlapping, which will retain some context from the previous by just like for example 1 to 1800 to 1800 and 1600 to 2600, something like that. The 2200 characters is retained. That is your chunk overlapping. Okay, so now that you understand chunk optimization or chunking methods, we'll move on to the vector store creation process. Okay, again you need to provide your variables that is there. Okay, now the first thing is multi-representation indexing. Okay, so it is very common that you'll have multiple documents. Okay, so what you will do is you will make a summary with the help of an LLM. Here it is GPT-4V or whatever LLM you have. You'll compute the embedding that will be in the vector store, but you'll also have your document in the document store. Okay, so once the question is provided based on the vector store and the document store directly, you'll have your relevant full document. Okay, not just relevant chunk, the full document. Because you see, with there are lots of people who find it hard to find, okay, I have multiple files. Now which file should I use, or how to find the appropriate file in which I should make the call? For that you will be using this multi-representation indexing. Okay, because common indexing is there. Okay, you can just provide to vector store and you will get the answer which we saw in the first video itself. That is fine. But if there's multiple documents, how we are going to handle it? That's why we have this. This is not just multi-vector. Okay, it is known as parent query retriever. Okay, parent retriever. Yeah. Okay. So here you are providing the web-based loader in which there are two URLs being loaded. Okay. One is an introduction to RAG and another one is introduction to agents. Okay. Two things are loaded here. Okay. And those two documents are summarized, asked to be summarized. Okay. Now those two summaries are obtained here. What we'll do is these summaries are there already, right? So what we'll do is first we'll be creating the embedding instance. Here we are having an in-memory byte store. Okay, this is if it is a byte store, it's not a vector store. Okay, this is just the doc store which I was talking about before. Okay, this doc store is your in-memory byte store. If it was vector store, it would have been your vector store. All right, so in-memory byte store is used. You have your chroma vector store, and embeddings is Hugging Face BG embeddings, and then the vector retriever is multi-vector retriever. Okay, so here the model name is BG small en, which is the smallest variant of BG models, and the device you are going to use is CPU, which means your model will be running on CPU, and embeddings are normalized with normalized embedding set to true. Okay, these are all just parameters by which the Hugging Face BG embeddings will initialize a sentence transformer model, or this HF embeddings is nothing but an object of BG base en model, or sorry, BG small en model, right? Now you will create a vector store. This is just an empty vector store. Okay, the collection name is summaries, in which the embedding function is HF embedding. So when you're going to add a document, the embeddings will be computed with the help of this embedding. All right. So this is about the child chunks. Okay, so when you talk about parent document and chunks, so you will say like documents are parent, the chunks are child. Okay, so for indexing the child chunks, you have your vector store, but what are you going to use to index the parent document? For that you have in-memory byte store. Okay, so here you'll have your doc id. Okay, the document id is provided. So for this you need to provide a multi-vector store retriever, where you are providing a vector store along with your byte store, which is again your document store, and the id key is also provided, which is doc id. Okay, which these documents are there. Now we are just providing a document ID to the summary documents. Okay, so whatever summary documents we created, for those we are providing this. Okay, now you'll add the documents to the vector store, and also you will set your document store with these document IDs and those documents, summary documents. Okay, I hope you will understand. Okay, this will look like complicated, but it is not. Okay, now here you can see the doc IDs are here, and if I say mget doc IDs, it will provide the documents which are there. Okay, now if I do vector store or similarity search, and what is agent, it will provide agent related answer. And if I had given related to this one, what is it, I even forgot, RAG, it would have given the RAG document. That is fine. Okay, but in this, if you see one thing, if I had multiple documents, right, I need not even chunk it. Actually, see, the chunks are summaries here, right? I need not even chunk it. Here you can see the character text splitter was there, but I didn't use it for chunking. Okay, this is used when you want to use multiple source documents. Okay, so if you can see, this is also kind of routing, but you are indexing multiple documents in a better way with the help of multiple representation. All right, so here I'm choosing the page here, and then probably you can move on to the chunks there. That is also possible. Okay, so yeah, that is parent document retriever, but that is not the fun part. The fun part is callbot. Okay, for callbot, there is an explanation, or it is an acronym, I think, which I'm going to explain now. Actually, the fun thing is, they should have kept it as colibot, because it is contextualized late interaction bot. That is the full overbot. That is the full form actually, but for some reason they kept it as callbot. I don't know why. Okay, there are some documents here. The first document is about how it uses, like developers can use Colbert to overcome their problems, and the second one would be about Ragatwheel. Ragatwheel is a library which will help you to make use of Colbert with ease. Okay, and then the third one is about how you can use Colbert with Ragatwheel. Okay, a blog on that. So all of these three links are available. You can use all of those. Okay. So for this, you need to first install Ratatouille. From they have been inspired from Ratatouille. Okay, Ratatouille, if you don't know, is a movie in Hollywood. Okay, again unrelated. Let's come into the topic again. So Ragatile is a library which makes our life easier to use Callbird. So I'm again emphasizing Callbird, Callbird, Callbird. What is Callbird? That is a question, right? So we'll see about that now. Okay. See, Callbird generates a contextually influenced vector for each token in the passages. Now you'll wonder, okay, Vasanth, you have been doing an okay job at least till now. I think I'm doing an okay job at least in this course till now. If you think like that, please hit the subscribe button and hit the like button. Okay. But yeah, coming again, you are saying contextually influenced vector for each token passage. Don't confuse me. Yeah, if you get that feeling, don't worry. I got the same feeling when I was studying about Colbert. You see, usually when you compute embeddings, right, you compute for the whole sentence. So it's like okay, Vasanth is teaching about advanced RAG. Okay, Vasanth is teaching about advanced RAG. It's not like that. Vasanth is teaching about advanced RAG. For the whole sentence, there is a 384 dimension embedding. But here, it will generate a vector such a way that it will be for each token in the passage. All right. So it will generate vectors for each token in the query as well. So for example, it's like, you'll do a word level search, right? Like, appropriate search. How many, for example, the Google search engine, right? The number of words available will be highlighted. But here, it's like, I'm not saying searching the exact word, but I'm searching a word which is closer. So it's like a word level search rather than a sentence level matching. Okay, that is why Ragatile is a very good method. Okay, so for this, it is not able to run in Windows actually. Okay, so I ran this in Google Colab, so you will be able to also be able to run in Google Colab. Okay, that is not a problem. So here we are using Colbert V 2.0 model, for which we are initializing with RAG pre-trained model, which is a wrapper class for pre-trained late interaction model. Okay, Ragatile. I like that name, Ragatile. Okay. Here we are writing a function to get a Wikipedia page, which will be our input. Okay. So this is the API or API endpoint, which will have these parameters. Okay, action and format, title, prop, and then explain text. Okay, the headers are provided where the header is the name is Ragatile tutorial blah 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 blah. Okay, you can provide whatever header you want. This is just username. You can even if I provide a neural hacks with %, it will be working. Okay, no problem at all. The response will be update. Okay, this is just to show who is making the call. So the response will be JSON, and then you will get the next page and all. Okay, that is to extract the page. Here I'm trying to extract a page about document retrieval. Okay, so here in RAG instance itself, there is a function called index, because you are indexing your document, right? So there is a function called index which will take a collection. The collection will be a list of documents you want to index, but here I have only one document, which is a full document of document retrieval. So you will put that collection under the index name doc1, and I'm saying okay, the maximum document length I'm allowing is 180. Okay, do I want to split the document? Yes, so split documents is true. Okay, here there are some warnings, please ignore all of those. Okay, so it is saying number of training points and so on and so forth. Finally it said okay, done indexing, and it is saying in something like it's a optimized IVF dot ragatile / callbird / indexes, and some explanation there. So if I call rag.search, what is an example of form based indexing? So it was a big URL actually, like whole Wikipedia page, and there was like some name there, form based indexing. So I just asked what is form based indexing, and now you can see it is computing the torch IDs for all of those, and finally it gave me an answer. Okay, there are two main classes for indexing schemas for document retrieval system: form based and content based indexing. the document classification schema in use determines for the nature of the document retrieval system, blah 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 blah. And finally, if you see at the last, it would say a suffix tree algorithm is an example for form-based indexing, right? This was amazing actually, okay, because it's like best of the both worlds. Okay, you are matching it at word level, but even if you don't have the same word, you will have something closer to it. If I had provided what is a demonstration for form-based indexing, I'm sure it would have given the same result. Okay, that is a good part here, because it is not always you will find yourself with para-level finding. Okay, there will be some times where, for example, invoices, if you want to do RAG over that, you need to be able to do it at word level as well. So at that time, this indexing will be very useful actually. Okay, so yeah, that is that indexing. Okay, there is another method as well known as Raptor. Okay, the thing why I didn't show Raptor right now is I'll explain about Raptor actually. Okay, but we can't show it because it is not something which I'll recommend actually. Okay, let's say you have a document. Okay, what you will do is you'll split those. Okay, and the LLM itself will cluster it together. Okay, there will be different number of cluster. Okay. So what will happen is a tree kind of summarization will be there, and all of those summarization will be clustered together, and then those will be used as documents actually. Okay, that is very highly costly and has very limited use case actually right now. I'm looking for a use case with Raptor, but still, if you want to have an idea about how Raptor works, you can see this document from LangChain itself, which is Raptor is first recursive abstract processing for tree organized retrieval. Okay, here you can see this process is done recursively. Here you can see, right, the raw documents are there. You will be vector storing it, you'll make the embeddings out of it, and you'll cluster closer things together. For example, these greens are together, orange and yellow are that is to show close things are together. So probably that is an advancement. Yeah, sure, I'll say it is sure. Okay, but it will take a lot of time. Okay, so what you'll do is you'll compute your summaries. This is like grouping contexts which are together. So let's say I have a document which has different concepts. Okay, and the different concepts are at different positions. So if I'm asking about result section, results and conclusion are at two sections, and those two are closer together, and those can be clustered together. If I'm talking about abstract and introduction can be clustered together. If I'm talking about the procedure, the methodology, those can be clustered together. Okay, so those clusters, what they're doing is, that is why it irritates me. You are first finding the cluster, that is fine. Okay, you are summarizing the cluster, that is also fine. Again, they are making an embedding out of those, and that becomes another cluster, and there again computing and summary there. No, it is like as highly how can I even put it, like it is very costly actually. Okay, you see here, like if I go to this, right, this Langsmith tracing, you'll be able to see actually the tracing. All right, so it will go to the retriever, and there are some documents, and they are formatting it, and they are giving an output. I think they haven't traced it correctly actually. Okay, actually it is very costly, because you need to the vector store creation process is very high. I think vector store creation, yes, won't be there. True. So the vector store creation is the one which has a lot of cost to it actually. So if you are going to see at runtime, it is going to not cost you a lot. But if you are thinking, okay, I have a lot of money and I'm more focused on performance, because with Raptor you're going to get very good performance, that is for sure. Okay, there are no two ways about it, but it is a very costly method. Okay, so if you want a video separately on Raptor, let me know. I'll make a video on it, because you can see, right, it is by itself a very big concept actually. Okay, I need to show you about KNN. They would have used some UMAP and all. I need to show about all of those to you. Actually, I'm sorry, I'm not able to show it now because yeah, it is too big for me to show in the timestamp I have right now. But yeah, Raptor is also a method. Like GraphRAG could have been inspired from Raptor. I'm not sure if they have a paper. I think Raptor would have a citation there. Because yeah, they are also doing some summaries actually. But yeah, that is what is about this video actually, because in this video now you saw about what you have to do when you have multiple documents, what you have to do when you want some specialized embeddings, like for simple words. When you will be very much useful with callbot is when you have domain specific words. So for example, if I'm asking about what is that asthma simple thing, okay, but if I ask something like uh, there is this long syllable actually. Let me search over internet itself right now. Okay, just give me a minute. It's pneumono ultra microscopic silicovolcanoconiosis. I'm not even able to pronounce it. It is 45 letters. It is a disease about people who get pneumonia, or like they get lung disease due to volcano actually. Okay, so because it has a silica material, it is siliconosis. Like they have tried to keep it as much as name as possible. But why I wanted to say is this, because if I ask about this, right, um it might not even understand, but it will look for the word, like pneumonia. Okay, I need to look something related to pneumonia, volcano and all. Okay, so it will see about those tokens. Okay, so that is where you will benefit out of callbot actually. Okay, again, like I said, if you have multiple documents, then you can use multi-representation indexing, and we saw what are the methods you can use for different chunking. Okay, and finally we also saw when you want to do no hierarchical indexing, you should follow raptor method. So yeah guys, that is about indexing. In the next video, which will be us moving towards intermediate, because you see we are moving towards all the advanced steps, then we'll have generation. Okay, but after that we'll focus on agentic rag, adaptive agent, corrective rag, local rag agent. There is GraphRAG. All of those are too advanced. Once you complete this self-reflection rag, right, that is a part of ours here, you are almost advanced or intermediate to advanced, that level. But when you know about these, you are X level. Okay, so in the next video we'll go on to the retrieval mechanism. After that we'll see about self-reflection rag. Okay, so yeah guys, I hope you like this video. If you like this video, please hit the like button. I request you all, because um this it's 4 day in, and I think I'm the first YouTuber to make a YouTube course like this on rag. I hope you all will be benefiting out of that. So if you want more people to benefit like you all, I need to get my video recommended to more people. For that, like is very important. So like it, share it with your friends, subscribe to the channel if you haven't subscribed, so that you will get the notification for courses like this. I'll see you on the next video. Until then, happy learning.
Hello everyone, welcome to the fifth video on the complete advanced RAG course. We are halfway into the course, and in this video we are going to see the methods which can be used while retrieval. You can do re-ranking, RAG fusion, or there are some other methods like conditional RAG and rank GPT. We are gonna see in this video on re-ranking, and we'll also brush up RAG fusion a bit. Why is RAG fusion also a part of this? We'll see once I explain about re-ranking. You will be able to understand why RAG fusion is also a part of this. There are some other things which you need to know, which is the prerequisites. You need to know about indexing, you need to have some clear understanding, because this is not the first step, this is the fifth step. And to know what are all the things which are to be used, I recommend you all to watch all the previous videos, where the last video was about how will you index documents to vector database, and for that we saw how you can use callbot and multi-indexing to do some advanced embeddings of the documents. Okay, so that was the previous video. Now in this video we'll be seeing about RAG fusion as a brush up, and we'll see about re-rank. Okay, so first, all of these are gonna come under RAG Fusion. Even RAG Fusion, sorry, all of these are gonna come under re-ranking, because even RAG Fusion is a form of re-ranking. Okay, so to know about that, it is very important that first you know what is re-ranking all about. You see, we are using a dense retriever, alright, and it is not always a fact that you will be finding your answer in the first document itself. Okay, so for example, you generated three questions and your first question gives an answer. It's not just that. Even if it is one question and you're getting three documents out of it, right? Top k is equal to 3. Still, the procedure is going to remain the same. But in RAG Fusion, it is not the case. Okay? The idea is that when you have one or more documents, sorry, two or more documents, and like I said, the most relevant document should be at the top, because the most importance is given to that document as per research. All right, so here it is like getting a second opinion. Okay, so whatever documents you have retrieved, what we'll do is we'll re-rank those. Already we are getting top k, which means it is ranked. Okay, the most relevant is the first one, the second relevant is the second one, third relevant is the third one. Okay, but we'll be making sure that we'll do a re-ranking, which is kind of a second opinion. What we'll do is we'll see how much this document is really at the first place. So for that, the first option would be you can use RAG Fusion. Okay, that is one option. And then there is re-ranking, which is flash rank re-ranker is there, cohere re-ranker is there. Even there is an option called ensemble retriever, which is in LangChain. Okay, so there what you will do is you will be taking two retrievers which will be combining together as one. Okay, I'll also probably add that also in the video here. Okay, so ensemble retriever is very useful when you want to you know get retrieval in multiple aspects, and we'll do that as well in this video, though it is not that there in that image. Okay, but now the point, I think you get it right. It is not always that you'll retrieve it in the correct order, so we are making sure that the correct order is obtained. So for that we are using the step which is re-ranking. Re-rank is nothing but it will check again. Okay, there is a question, I have three documents, which is the most relevant, that will be again checked. So you can't use the same model. All right, you will be using a different model for re-ranking. Now, how is RAG Fusion also a form of re-ranking? Because if you remember reciprocal rank fusion, which we talked about before, it is like you'll be having three questions. Okay, and those three questions are gonna say a document. Okay, so we'll go for the example. I think you all have watched the video of RAG Fusion. I'm not going to explain in detail. Okay, here you can see the question A has ranked the document 1432, and question B as 3124, and question C as 4312. Okay, but when you do it for doc level, right? For example, it was previously 40312. Okay, and you're doing reciprocal rank fusion here, but the order is now changed, right? It is 1342. It's not 4, what was it, 4312. Okay, it is 1342, right? So here basically you're re-ranking whatever ranking is provided by your model. It's not just you need to do rank fusion. For rank fusion, it is this case. Okay, you need multiple options, or it is not like you should generate questions. RAG fusion can also be done with different models. Okay, so you can provide it with, for example, I have BG base, and then there are some other models like probably GT large, and then I'll go for MXBAI. I will take the opinion of all the other models. Okay, but my sample set would be 4. I'll then tell them to rank. Okay, I'll tell BG base to rank, and then I'll say other two as well, MXBAI and probably GT large. And from there, again, you can repeat the same process. Rank fusion is just a method where you have multiple option of documents, and you're going to combine those together as a single one, but not just sandwiching it, but finding some relevance in there. That is about RAG fusion. Okay, so technically you are also re-ranking the document. That is why it is falling under re-ranking. Okay, that is one option. But you can also use a re-ranker known as flash re-ranker, which is available in Hugging Face itself. Sorry, not Hugging Face, LangChain. Okay, so for this you will need first one thing, which is contextual compression retriever. This is just a retriever which will wrap the base retriever and will also compress the results. Okay, here here if you see in retrievers document compressors, because we are going to compress the document. Okay, in there we are going to use flash rank re-rank compressor. Okay, this is just an interface for flash rank re-rank. This is just a package. Okay, this is a very lightweight package, flash rank, and from there we are also importing ranker. Okay, this is a ranker class which will be re-ranking passages for a given query by using a pre-trained model. Okay, and here there is a request which you can pass. These two are just some imports which are required to avoid an error. That's all. Okay, these are not some imports which we are going to use. And by the way guys, I'm not going to explain the reciprocal rank fusion and all in detail, because I have already explained in the query transformation video, so please take that. Okay, with that being said, now here if you see, I have a vector store. Okay, which was created in here with where it is, yeah, here you can see I'm using bg small en in cpu as usual. And the splitter, if you see, you can also use tick token encoder. Okay, tick token is a package or like that is a format of encoding or tokenization which is used in gpt architectures usually. Okay, so what it will do is, rather than split it at characters, it will split it as tokens. Okay, so 300 tokens is the max limit and chunk overlap is 50. You have splitted the document. Now you are making an embedding instance, and a vector store is created from documents, which is chroma vector store, and you have provided your chunks and the embeddings. Now this is your retriever. Okay, this is your dense retriever. Make sure that you highlight that. Okay, your dense retriever is ready. So here for contextual compression retriever, you need two things. One is a compressor and then another one is a retriever. Make sure that when you use flash rank re-rank, you call the update forward refs function, because it will be able to update the forward refs on the field based on the model. Okay, here you'll be providing your base compressor, which is your flash rank re-rank compressor, and base retriever is your retriever, which is a vector store. Okay, the search keyword arguments here, we are taking top 10, because when you are re-ranking it and you are taking top k, right? The higher the value, it is better to use re-ranking, because if you have just two documents, it doesn't make any sense. But with 10 documents, 15 documents, that is when it is very important that you place your correct document at the top, because that is when it goes out of the context. All right, so here when you call the get relevant documents function, similarly as how you'll call for normal retriever as well, if you call it and provide a question, which is, where is it, I think the same one, no, what is the task decomposition? Okay, as usual in the old videos, if you ask that, here if you see, it is giving me an answer. There were only two chunks, I guess. So it was trying to provide the three chunks, but here if you see, it is re-ranked. Okay, previously this was first and this was second, actually now it is re-ranked, right? So yeah, you can see it is relevant score 0.999, and here it is 0.9924, here it is 2152. Okay, the relevant score is also there. All right, so yeah, that is about re-ranking. Now there is another method, which is ensemble retrieval. Now coming on to ensemble retriever. Ensemble retriever is a retriever which uses reciprocal rank fusion at the back end, but in multi-query retriever, if you remember, we are using multiple question, and question acts as our model actually. But in there itself, I explained, right? You can provide multiple models for same set of documents for a given question, and those models will decide, no, which is higher, which is lower. The logic remains the same, because ensemble retriever uses reciprocal rank fusion, and here also if you see, the k value used is default by 60. Okay, so here what we are going to do is, usually ensemble retriever is well used with a combination of a dense retriever along with a sparse retriever. For dense retriever, we already have our vector store retriever, which we created by using chroma. Okay, the chroma vector store, which is acting as a retriever, is working here, which is using Hugging Face BG embeddings. But for sparse retriever, we need a retriever for which we are going to use BM25. BM25 retriever is a sparse retriever which will work based on the probabilistic values of the names or words, occurrences and all. Okay, though that is why it is a sparse retriever. And BM25 is an old method, like it's a very old method. I think it's a 40-year-old method, and it also uses TF-IDF kind of a logic at the back. All right, so that's why I said it is based on the occurrence. So when you have something like an extraction, all right, that is when you will benefit most with the help of this ensemble retriever, because if it is an extraction, there might be a possibility for you to have your direct value itself inside the document. So at that time, it is easier to obtain that value with the help of a BM25 retriever rather than a normal retriever. But there are chances where you will find yourself that the direct value might not be there. That is when your dense retriever, which is your vector store retriever, will come into the picture with very handy being very handy. Okay, so that's why you have ensemble retriever, where you will be providing your BM25 retriever and density retriever, but here you also provide weights. Previously we were dividing it by 1 by the value, right? Instead of dividing it that, once that is done, you will be multiplying it with weight. Okay, so that's why weights are provided. Here I'm saying BM25 retriever and density retriever are equally important, but depends on the use case, you can give more importance or less importance to a retriever, okay, or a type of retriever. So that is why weights are there. You can provide your importance. Once I invoke here, you can see previously it gave this AI LLM powered autonomous agents as the most relevant document, okay, and the second was this one, the overview of LLM powered autonomous agent. But the exact value or the exact name of task decomposition seems to be available in the first document rather than this third document. Okay, now see, you are getting probably the answer might be better in this first document rather than the third document. Okay, that is why you need this thing. Okay, but again, if you see here, when you go to 3 and all, right, the I the chance of you getting an answer from this third document is very less. That is why you have another thing which is known as long context reorder. This is a document transformer, okay, but this is also used post retrieval or in the retrieval stage itself. Okay, so let's say you have retrieved like this. Okay, this retrieval itself is there, but here I've just made a simpler model which is all mini LM, and again I made a chroma and I made a retrieval here. Okay, this is giving me again 10 documents, and when I call the transform documents function in long context reorder, what it will do is the order will be like, okay, here you can see the difference. Okay, now let me zoom out. Here you can see, right, the most relevant came into the bottom and the second most relevant at the top, third most relevant at the bottom, fourth most at the top. Okay, because the most importance are given to end and then beginning. It will reorder in that way. Okay, you can write a Python logic for this, but there is a person who have already done this, so it makes our life easier. Okay, so when you retrieve more than 5 or 6 documents, it is very highly likely that at some times, if there is your answer in the third or fourth, your chances of getting an answer from the third or fourth document is lesser than getting it from one, or if it is three, the second document. Right, so for that only we are using this long context reorder. Now there are some other retrievers as well, which was covered as a part of others, because we can call it as a retriever, but it is not optimizing the retrieval part. For example, the first one is multi-query retriever, which is you'll transform your query and those queries will be used for retrieval. So that is covered in query transformation. Please check that in detail. Okay, but as a summary, what will happen in multi-query retriever is, given a question, you will try to compute you know uh, 5 different questions with some different perspectives of the same question, but in similar meaning, and you will do a retrieval for those 5 questions. Okay, rather than taking one question 5 documents, you will take 5 questions, and for each question you will take the topmost relevant document, and from there you will provide your context for answering. That is multi-query retriever. For multi-vector retriever, we already saw that you can use a doc store as well as a vector store. You can hand multiple documents with the help of multi-vector retriever, and parent document retriever is a type of multi-vector retriever. We saw that in the indexing video. Now in companies, there is always a chance that you will have a metadata. Okay, so this is for those use cases. Okay, let's say you have some sales data, or any data which has a metadata to it, and you can filter by that as well. Okay, in that case, what you can do is you can create your document in this way. Okay, it expects this kind of a structure. You should call your document with a page content, and you'll provide your page content is nothing but your normal chunk. Okay, and you should provide a metadata for the chunk. For example, this is about movies, and here I have provided a chunk metadata that okay, this is a 1993 movie. It is a science fiction genre, and the rating is 7.7. This is a description of the movie. So similarly, there are some other values as well, but it is not necessary that you need to provide the same value. Okay, for example, director was not there, but director is provided here. Okay, so make sure that you provide the metadata correctly. That is fine, but all of those, like I said, is not must, but all of those need to have an explanation, all those attributes. For example, director was not there in all chunks or all your data points, but you need to say director. What is the director field all about? What is your year field all about? What is your genre field all about? No, here you can see we are also saying okay, this might be only of these values. Okay, so you need to provide that attribute info. Okay, so you are constructing your docs like this. Usually it will be just document of page content and metadata will be empty, but here you are constructing it with metadata, and you are calling your vector store chroma.from document and docs, and your embeddings are provided as usual, which is your HF embeddings, which we already created by using BGE base, or rather BGE small. And here you are providing the metadata field info, for which you should use attribute info, which is imported from langchain.chains query constructor dot base attribute. Okay, because this is also a way of constructing a query, right? Because rather than providing a question on I need a science fiction movie, here you can ask okay, I need a science fiction movie which is from the year 2019 of next Christopher Nolan. Now you'll get more accurate results, so that's why they have put it under query constructor. And here you can provide attribute info. Okay, the name, description, type are important. Okay, what is the type means nothing but your data type. Description is about a description on the field, and name is the name of the field. Okay, you can provide those. It should be a list. All right, now you have your document content description. I need a brief summary of a movie. Okay, these are all about a brief summaries of a movie. For example, this is a movie and we don't know the movie name, but these documents are about brief summaries of movies. All right, that is document content description. You are providing a metadata field info which you created here, and then your vector store, and then your retriever. For this you should call your self query retriever. Okay, so if you do retriever.invoke of I want a movie rated higher than 8.5, here you can see it will only give movies which are greater than 8.5 of rating. If I say has Greta Gerwig directed any movies about women, a moral blah, 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 something is there, but here you can see the filter is about Greta Gerwig. And if I provide this, and here you can see a bunch of normal size women, it will say yes. Okay, so if I say what's a highly rated above 8.5 science fiction film, it is going, here you can see the rating is 8 point something, and here alone it failed. Okay, the genre should have been science fiction, it went for thriller. Probably it gave more importance to rating rather than science fiction, but you get the idea, right? Now if we have your metadata, just think, you can for example, if you have some chat, I need a chat about this. For example, this is a discussion forum, and I need information from this discussion on specific some date. Okay, it will be able to get chats from that date, and you'll be able to answer your question. So that is a use case which can be solved with the help of this retrieval mechanism. Okay, so yeah guys, actually we are halfway done, because in generation there are not a lot of things which you'll be able to do. Post generation there are some things like self reflection in RAG is one aspect of that. Okay, that in itself is a very big concept. Okay, So for that, we'll see it in the next video, that is going to be on generation, and for this we'll hereafter we'll be using langgraph. All right, so yeah, that is about this video, where in this video we saw about many retrievers like a rag fusion which uses a reciprocal rank fusion, and then we saw re-ranker by using flash rank re-ranker, but there is also query ranker. There is multi-query retriever, multi-vector retriever, parent document retriever, self-querying retriever, long context reorder. We saw about all of these, and yeah, now you can use it for any of your use cases. Wherever you think this will be useful, you can just place it there. So yeah guys, I hope you like this video. If you like this video, please hit the like button, share it with your friends. If you haven't subscribed to the channel, please hit the subscribe button, hit the bell icon, and let me know your thoughts in the comment section about how much you have liked this course till now, because we are actually halfway into this course. So just let me know, how do you feel about RAG now? Do you feel like, okay, I am very good with RAG? If you get that feel, let me know. So yeah guys, I'll see you on the next video. Until then, happy learning.
We have been seeing about advanced RAG a lot, and here is a video on self-reflection RAG. Self-reflection RAG is a method or a strategy for RAG that incorporates self-reflection or self-grading on retrieved documents and generation. And in this video, we are going to see in detail about this method. Let's start with the video. For this, as usual, we are setting up our environment variable, right? So for this, we are going to take 3 blog posts. Everything are from Lillian Weng github.io about prompt engineering, adversarial attack, LLM agent. Okay, so these 3 are the URLs which are our target URL, which we are loading with the help of web-based loader, which will use Beautiful Soup to load the website. And here we are getting the documents by loading the URL by calling the dot load function after we provide the URL, and those document are provided as document list, which are then chunked with the help of recursive character text splitter. By providing chunk size as 250 and chunk overlap as 0, we'll split the documents. Okay, so that becomes your doc splits or your okay. So now to compute embeddings, we have BG embeddings, which is going to run on CPU. The embeddings are normalized, and we are using Hugging Face BGA embeddings, in which we have provided our model name, model keyword arguments, and encode keyword. Now all we need to do is we need to provide our HF embedding, and we need to provide our chunks, which we want to store in the chroma vectors, which will act as our. Now it's running, right? So now the next thing is first one. See, we have talked about a lot of components here. We need to grade your retrieval, we need to grade your generation, and like hallucination grader if you want to put that way, and then answer grader. Okay, we need 3 graders. Okay, and now we are going to create all those 3 instances. Right, now it's running. Leave that. Here we have our retrieval. So in retrieval grader, if you see, we are going to have a data model first, which will be binary score. All I need is to know if the given document is relevant to the question or not. Okay, if it is relevant, just say yes, or if it is not relevant, just say no. Okay, that is what we are saying here. And for this, we are going to use Groq LLM. And since we are not providing a name, it is going to run Mixtral. Okay, sorry, yeah, Mixtral 8x7b32676768 is the model which is going to run, and we are getting the output from the LLM with the structured output following the data class or the data model which we already wrote here, which is grade documents. Okay, so whatever output it is going to give, it will be about binaries. Okay, so here you need to provide a prompt for the grader. Okay, so we are saying you're a grader assessing relevance of a retrieved document to a query. It does not need to be a stringent test. The goal is to filter erroneous retrievals. If the document contains keywords and is semantically close to each other, grade it as relevant and give a binary score whether it is yes or no. Okay, and now we are creating a prompt template with the help of chat prompt template with the message we already have here. Okay, system prompt is already provided, and for human we are going to provide the retrieve document by adding slash and slash, and we'll be providing the docs we retrieved at any given time step. Okay, and then similarly we'll be providing the question as well. For example, here is a first here is a chain of retrieval grader. Okay, it is just a grading prompt which will create your prompt which will be sent to your structured LLM grader. Okay, so that is your retrieval grader. Once you provide your question agent memory, what it will do is will retrieve the relevant doc for the given question, and we'll just take one document out of it. Okay, that becomes a doc test, and the page content is obtained. Page content is nothing but the content. Okay, and then what we are doing is we are invoking the retrieval grader with the question as question and document as doc text. Now if you run this, it will try to retrieve the relevant documents, and it is going to say yes. Okay, so if you go and see about doc text, if you see short term memory, and it is about agent memory, so it is relevant. Okay, so that is why it has provided binary score as yes. Now we need to generate an answer, right? Because if you see, all we are doing is now we are creating all of these nodes. Okay, because for retrieval we don't need a node, just gonna be a normal retrieval. For grader we already written a grader. Now next we need to write a generator. Okay, then we'll make a hallucination grader, then an answer. Now let's see about generation or a generator. Okay, so for generator what we are doing is we are taking RAG prompt, which is nothing but a simple prompt about context question, everything will be provided in there. And here we are gonna use the same chat Groq LLM, and here we are using format docs function. And in the previous part itself, a lot of people asked about format docs. Format docs is nothing but a simple function which will be for example, I retrieve document 1 2 3. Okay, it will be list. Okay, so here what I'll do is I'll be combining all of those document with slash and slash and as separator. That is what is format docs function gonna do, right? So yeah, that is for post process. Okay, so whenever you require you can do that, but I don't think we'll need it here. Okay, so here what we are doing is we are using the prompt, we are providing the LLM. Okay, so once you provide your question, it will be formatted with the prompt, where you also need to provide a document. Okay, the keys are context and question. Once you have provided it, your prompt is ready, which is sent to your LLM, and a string output parser will parse here. If I provide run, gonna give me an okay agent memory. Okay, but yeah, it is working. Now next is hallucination. So if you don't know about hallucination is nothing but something about the concept, and you are gonna say something related to it, but it is not gonna be based on the context. Okay, so for example, I know sun rises in the east, so if I ask which country does sun rises in, let's say I will say Saudi Arabia. I'm from America and I will say Saudi Arabia, because Saudi Arabia, I think it's east to America. Okay, that is like, but the real truth is it doesn't rise from. Okay, so the context might say, like, let's say for example Japan. Okay, so it should say Japan rather than from east, so it is Saudi Arabia, something like that, or the east corner of. So I hope you get that point. All right, so now you have your hallucination grade. All right, now that you know about hallucination, rather, let's create the hallucination grader. Okay, so here again we are creating a data model which will be about a binary score, where the description is answer is grounded in the facts. Okay, so I have provided you the facts, and answer is based on the facts, yes or no. Okay, so what you need to do is you'll provide your LLM, and you are invoking your LLM with structured output based on the data model which is already provided here. And once you provide your system prompt, you are a grader assessing whether an LLM generation is grounded in slash supported by a set of retrieved facts. Give a binary score yes or no. This means that the answer is grounded, and it's to just show that the answer is from the context. Okay, which means it is to avoid hallucination, right? So yeah, here we are gonna provide our prompt in the chat prompt template. So for that you'll be providing a system prompt. Along with that you have a human, which is gonna provide your human input, which is set of facts and your documents, and then LLM generate. Okay, so what is the answer generated by LLM? So the hallucination graded is the hallucination prompt will be passed to the structured LLM grader. Okay, so once you invoke it, the documents and generation will be applied here, and based on this it will say whether it is hallucinated or not, whether the answer is hallucinated or not. Okay, so here yes is a good thing, it is not hallucinated. Okay, no is a bad thing, because we said that yes means that the answer is grounded in or supported by the set of facts. Okay, so it means a good thing. By this you can avoid a lot of things, because there is always a problem that you might face. You'll be retrieving, and answer might not be something you expected. Okay, That might be because context is retrieved wrong, LLM is hallucinated, and all of those can be solved with the help of self RAG because we are grading it at every step. All right. So here we have an answer grader which is going to do the same. Okay. This time I'm not going to explain. You have your data model which is about answer addresses the question. In there, you have a system prompt to say you need to you are a grader in assessing whether an answer addresses or resolves a question. Okay, and it should be a binary score, yes or no. Yes means that the answer resolves the question, and no means it doesn't. Okay, so as long as you get yes, it means. Now if you see, we already talked about the other comp, right? So here we are done with retrieval, grader of retrieval, and generator, your hallucination grader. Everything is done, even answer grader. So it at some point of time, if it is about no, okay, the document is not relevant or it doesn't answer my question, I need to rewrite the question. Okay, because if I rewrite the question, I might get a better result. This is in the advanced RAG course part 1 itself. I would have said about multi-query retriever, right? So that also can be applied here. Okay, so here is a question rewriter. You are a question rewriter that converts an input question to a better version that is optimized for vector store retrieval. Look at the input and try to reason about the underlying semantic intent slash meaning. Okay, so a more specific and vector could be, can you provide a summary, a key points and the information stored in agent's memory? Okay, so this is a question which is already there. You can provide models like, for example, model name equal to, if you give something like llama 370b 8192, you'll get a better. Okay, why I didn't use llama 370 billion is because it is too cost. Okay, here if you see, the question is, what is the concept of memory in artificial intelligence age? Okay, and if you say, just say the quest, here it is going to say what is the concept of the memory in artificial intelligence. Okay, the post that it won't be there for some other content. If I again prompt it to be like, I don't any explain, just question is, probably this should be giving the question. Yeah, what is agent memory in artificial intelligence? Okay, you can prompt it like this. So even if you give like this, it is going to give, okay, what is the concept of agent memory and how does it. All right, so here you're changing the question so that you have a possibility to get a different answer which might or might not, and you're not going to worry because that is going to be in loop. Okay, but how are we going to make all of these in loop? That is where we are going to use langgraph. Right, so for langgraph, here we have graph state. Okay, graph state is nothing but it is like a dictionary. Okay, and it has all of those values which you will require or you will add in any point of time in your graph. It is like a state at any point of time in the graph, and what are all the attributes that state represents. Okay, so for example, there will be question, generation, documents. These are the things which will be the states we'll require. Okay, for node we need a retrieval node. Okay, so for that we are using retriever get relevant document. For generate, we need question as well as relevant documents. Here you can see, like I said, that is kind of a data. For retrieval you need just question. Okay, so you retrieved it, and once you return, what it will do is it will just change the state. Okay, and in state itself there is documents, right? So for documents it will change it with its documents, and similarly question is again kept. So make sure once you provide question, you also add your question in retrieval, I mean return. Okay, so similarly for generate, you're using the RAG chain which we created previously, and you're invoking it with context and question. Okay, now you are changing the state from documents to documents. Question is also changed, and the generation is also provided so that you have your. Okay, now you have your grade document. Okay, so grade documents is to grade the documents based on the question. So you will require a question as well as documents. We are going through the document, we are invoking our retrieval grader to check if the document is relevant, and we are seeing if the grade is yes, and if it is yes, the documents will be appended to filter documents, and if it is no, we'll just continue. Okay, now the documents was previously these documents, and now we are changed it to filter documents so that only the relevant documents are there in the state. So similarly, we are calling a transform query node, which is to change the question. Okay, question rewrite is invoked here, and here you can see the question is changed into a better. Okay, so similarly, generate. So these are all about these. Okay, these were all nodes, your retrieve, your retrieve, grade, rewriter, generate is all fine. But these conditional things are there, right? These are known as edges. Okay, and now we are gonna create all of those edges. Okay, so the first edge is should I generate or not, which means I need to find if the documents are relevant or not. Okay, so if the documents are relevant, I'll be returning transform query. Okay, sorry, if all the documents are not relevant, I'll be returning transform query so that only relevant documents are retrieved, and if it is relevant, I'll be returning generate. Okay, this is about the node names. Okay, already I wrote here transform query generate. Okay, so which node is to be called is edge. Okay, a graph is constructed with the help of node and edges, and here we are deciding which edge it, and these kind of edges are known as conditional edge. Okay, so for this we are using the filtered documents, and if all of the filtered documents are not relevant, we'll be changing the query so that you will ensure that all are relevant documents. Based on that, we'll move on to generate node. Okay, create generation, the generation with respect to question and answer documents. Okay, so it will be used to determine whether the generation is grounded in the documents and answer in the question, which is nothing but your hallucination checking. Okay, so it will be checking if there is a hallucination. Okay, the hallucination grader is called, and here you are getting the binary and if there is a hallucination which is here else, you'll just return not useful. Okay, and sorry, here not supported. Right, the generation is not supported retry because it is not a good one, it is hallucinated. But if it is not hallucinated, it is grounded. Okay, now what we'll do is we'll grade the answer. Okay, so you got your answer, we'll grade the answer by using the question and generation, and if that is yes, we'll return use. Okay, so that we can end the loop, and if it is not useful, we'll use not useful so that the loop is not ended and it will continue. Okay, so you can go through the code once. It will be a bit hard to start with, but once you get a hang of it, it will be very easy to understand. Okay, so now we'll create a lang graph for which you are going to use state graph to create the state, and in the workflow we'll be adding nodes: retrieve node, grade document node, generate node, transform query node, and here we'll be adding edges like from retrieve I need to go to grade doc. Okay, so for these you need to refer this. I need to from retrieve I need to go to grade document, and from there I'll add a conditional edge whether I want to go to rewrite question or generate, and from there I'll add a conditional edge whether there is a hallucination or not, and then from there I'll add a hallucination edge to grade the answer, and if it is an answer we'll go to end state, and if it is not a answer we'll go on to retrieve node. Okay, so this kind of structure is did here. Okay, here you can see if it is useful we'll do end. Okay, and if it is not useful we'll do transform query. So this kind of thing is done here, and here we'll finally call workflow.compile. And if I ask here explain the how different, yeah, here it is, different types of agent memory work, what it will do is it will, here it is going to retrieve node, and if it is checking document is relevant. Out of 4 document 3 is relevant. Okay, so it is just checking. Okay, I'll go again. It is going to grade doc. Okay, now grade documents is completed, it is going to generate state. So retrieve state is completed, it is going to generate state, and now it is checking for hallucination. Okay, this kind of process will be slow. Okay, but it will get an assured answer than how you will get with a simple RAG. Okay, so that is why it is one of the advanced RAG method. So here you can see it made a decision that generation is grounded in document, it graded the answer and finally gave an answer. Okay, so here there is like a detailed answer. Sure, I'll be happy to explain. In an LLM powered agent system there are 3 types of memory: short term, long term, and it is a big answer, it gave an answer. Okay, and you can also provide it for another question, which is how chain of thought prompting. Okay, and that is how you will be able to make sure that you'll be getting a very good answer with the help of self RAG.
We are going to create an advanced RAG strategy, which is adaptive RAG strategy, that combines self-corrective RAG, which is also a self-reflection RAG if you want to put that way, and along with that we'll be adding a component known as query analysis. Here is a sample architecture or a sample diagram of the architecture which we are going to build. So given a question, what we'll do is we'll be making a query analysis, and we'll be checking if it is related to the vector store index we created or if it is not. If it is going to be related to the index we created, then we'll go on to the pipeline which we already saw before, which is self-reflection RAG pipeline. Okay, and if it is not, then we'll be moving on to the pipeline which is related to web search. So we'll be searching over internet and giving an answer just to make sure that there is an answer provided if there is not an answer which is there in your vector store. All right, so that is the idea of adaptive RAG, because now the LLM agent or the RAG agent which you are creating can adapt itself to the situation it is being put into. Okay, so for this, first you would need to set up your .env file, and inside the .env file you need to provide your Groq API key, LangChain API key, which is for your Langsmith, and also you would require to put your Tavily API key as well. Okay, because we would need web search and all. So for that, once you are done with that, you can move on to the first step, which is to index the document. Because if you do all of these, the first step is to find if that is there in index, right? So for that, you need first your documents to be indexed, and that's what we are going to see. First, to build index, what we are doing is we are using the PG small en model, and the keyword arguments are set as the device to CPU because we want to run this model in CPU, and the encode keyword arguments are such that we are going to set that we need to normalize embeddings. So for that, we are setting normalize embeddings to true, and based on this we are creating an instance of Hugging Face BG embeddings which will create an Hugging Face BG embeddings instance or an object which will be helpful for us to make embeddings. Okay, now what we are going to do is we are going to take out these three URLs, and for these three URLs what we are going to do is we are going to load all of those with the help of web-based loader, which uses Beautiful Soup. And once that is done, we are going to chunk it with the help of recursive character text splitter. And what does this from text tick token encoder does is that instead of doing character level, it will go at token level generated by the tick token encoder. If you are wondering what is tick token, like that is the tokenizer kind of tokenizer which is used in GPT kind of architectures, which is basically any LLMs. Okay, and the type of encoding it follows is, or the type of tokenization it follows is byte pair encoding. Okay, so now you are calling the split documents function of the text splitter for your documents list. Okay, so now you have your chunks here. All it is required is first you need to create a vector store with the help of chroma.from documents based on the chunks and the collection name and your embeddings you are provided. Then you can make a vector store as retriever, which will act as a retriever when you wanna make your RAG pipeline. Okay, now like I said, your indexing is done. Okay, here you need to make a router. Okay, this query analysis is nothing but a router which is to decide whether I wanna go with my vector search or should I go for web search. There are two pathways, but if you want, you can add more routes. For example, you can make a GraphDB and there you can route it, which we will see soon enough in one of the next videos, which is about knowledge graph RAG. Okay, so we will be seeing how you can create an RAG which will use knowledge graphs, but we are not going to use GraphRAG. We are going to create a knowledge graph by ourselves. Okay, I hope you would all be enjoying that. But with that being said, you can add any number of components to it. Okay, so that is the beauty of this architecture. You can add multiple data sources, you can add multiple pathways of your RAG. Anything can be done there, and for those we already saw about data source routing and all, query construction, those kind of stuffs in the advanced RAG course part 1. So if you haven't checked out video, please check it out. The link is in the description. So with that being said, now let's create a router. Okay, so for your router you need your LLM, which is Groq, and you need to create your data model, which is just an instance of base model. We are giving the name as router query, And the data source can be only two values. One is vector store, another one is fields vectors web search. And the field is such that the description is given that given a user question, choose the route, choose to route it. No, should you want to go for a web search or a vector store? Okay, so that is your router. Now, if you call your chat Groq with a temperature of 0, what happens is it will by default use Mixtral. Alright, and if you are using Mixtral, it means you can use the structured output as well, because with Llama 3 8 billion, it is tough to generate with structured output, and the same goes for any other smaller models. Okay, so that's why I left it as Mixtral itself. And here, what we are going to do is we are going to provide the router to provide an output of what data source should I go for. Should I go for vector store or web search? So now your LLM is ready. All we need to do is now provide a prompt. Okay, because you have said what kind of an output you are expecting. That is fine. Okay, but what is the task all about? You need to give that kind of a prompt, if you want to put that way. Okay, here you can see you're an expert at routing user questions to a vectors or vector store or web search. Now, actually, before going into here, it is very important for this line, because if you all had wondered, okay, Vasanth, how would the LLM know what is there in my vector store? Which is a very, very fair question. And if you thought of it, kudos to you, because that is why exactly we have the system prompt. Okay, the vector store contains documents related to agents, prompt engineering, and adversarial attacks. Use the vector store for questions on these topics. Otherwise, use web search. Because why are we providing it in prompt? Okay, first thing, we can't say what is there in the vector store, because it wouldn't make any sense, to provide the whole document if we are gonna make, provide that as input. But what are the documents are there in the vector store. Okay, so all you are doing is just giving a hint to the model that, okay, these are the documents which are available in vector store, so at least it is worth for you to search over. Okay, and if it is not there, it is gonna fail and it is gonna go for web search. That is fine. Okay, but at initial stage we are saying that, okay, if it is related to agent, go for web search. Vector store search, and if it is not, go for web search. That is what we give here. And we are using prompt template, where we are saying the system message is this and the human is asking a question, which is here. Okay, so what will happen is, first the router prompt will be created and it will be given to the router. So when the question is who will the Bears draft first in the NFL draft, and now it is not going to fall under agents, prompt engineering, and adversarial attack and all. So what it is doing is, it is saying I need to do web search. But if I am saying about agent memory, I'm gonna go for vector store. That is what is given here. Okay, now your analysis component is ready. Okay, here analysis is ready, but now you need to go for this path related to index. What if your data is related to the index? So now let's see about that. Okay, retrieval grader. So the first thing is, let me explain what is happening here. Okay, so once you give retrieve, we'll be making a retrieval grader which will grade if the document is relevant to the question or not. If it is yes, then only it will go for generation, and if it is not, we will rewrite the question and then we'll do the retrieval process again. But here, once you go for generation, it will generate the answer and we'll see if there is a hallucination. If it is there, and if there is an hallucination, which means it didn't respond according to the context, we'll ask it to generate again. But if there is no hallucination at all, we'll make it answer the question. And if we see there is an answer, then it is fine. If it is not, then we will rewrite the question and make retrieval, because since there is no hallucination, it means indirectly that directly that the context is wrong. Okay, that is why the answer is wrong there. So we'll make the retrieval again. Okay, I hope you all get the pipeline of self-reflection, which I already said in detail in this video, but we are also going to see about that in this video, and then we'll also see how the routing happens for web search and vector store and all soon. Okay, now let me be quick a bit, because this video is not about self-reflection RAG. So if you want to know about that, please check the link in the description. Okay, first thing is retrieval grader. You need to grade your documents based on if it is relevant or not. Again, we are creating a base model or the data model, which is grade documents. um, this is nothing but a Pydantic model which will say that you need an output which has this variables and all. Okay, so we are asking a binary score if the document is relevant or not, as yes or no. And here in the system prompt we are saying that your grader, the basic idea is that it should see for containing keywords, and the document should be semantically related to each other, and if it is, then it is a relevant one, and if it is not, it is not a relevant one. And we are saying it should not be a stringent test, so that it's not very strict, and it will give some leniency for its grading. Okay, so when we provide a user question, what will go is it will go through the grade prompt, which is the chat prompt template, which is created by system prompt, which we already said here, and the human, which is the question, will be like retrieve document is this, and the user question is this. Now say me the grade, something like that. Okay, and if I'm taking only, you can do this only document by document. Okay, it's not like parallel. You need to do it sequentially for every document you are retrieving. And if I say here that I'm gonna invoke my grader, it is saying yes. Okay, which means the retrieve document is relevant to the question, because at sometimes if the document is not there, it is gonna say like it is not relevant. So yeah, that is very useful. Right now, like I said, you're grading your retrieval, that is fine, but if it is relevant, then we need to generate the answer. So for that we are using LangChain Hub prompt. Okay, so there is a RAG prompt which is already available, and we are going to use that directly instead of writing by ourselves. Okay, and for LLM we are using Groq, and for post processing, and basically I haven't used that. Actually, this is a common thing which is there, but it wouldn't be needed actually. Okay, now for RAG chain, what we need to do is we need to provide the input through the prompt, which has two variables, context and question, and that will be provided to the LLM, and the output will be parsed with the help of string output parser. So once you invoke the RAG chain, it will provide an output like context is to docs and question is to question. Okay, so once you get this output, you can print that output as well. Right, so I hope you all get about this node, which is, this is basically your RAG. Okay, given a question, you are making a prompt, you are providing it to your LLM, and you are passing your output, and you already know what are your relevant documents based on what you graded before. Okay, but what if your generated output is wrong? There are two things possible for that. One is the retrieve context might be wrong again, and another one is your LLM hallucinated, and now we are going to solve that issue. Okay, so for that, first we are going to grade the hallucination. Okay, and we are going to see if it is grounded in facts or not, based on the context we provided. All right, if it is from the context, it means it is not hallucinated, and if it is not from the context, it means it is hallucinated. Okay, so here if you see, for the field description we have provided answer is grounded in the facts. So it means if yes, it is not hallucinated, and if it is no, it means it is hallucinated. Okay, now again for LLM we are using Groq. We are initializing the LLM with structured output to provide a binary score to check if it is grounded in facts or not. And the system prompt is going on a way such that stating that it is a grader, and it will help to assess whether an LLM generation is grounded in or supported by a set of retrieved facts. And if it is grounded, then we'll say yes, and if it is not, we'll say no. And here we are providing the set of facts, which is nothing but your documents, and your LLM generation output as generation. Okay, now where are we get this generation? Here, whatever answer is generated from your generate state, that will be used here. Okay, I hope you all get that. Okay, so once your hallucination is saying like, okay, this is not hallucinated, which means it is yes here, which means it is not hallucinated, then we can move on to grading your answer, which is again gonna follow the same procedure. I'm not gonna explain again and again. It will again say binary score whether it answers the question or not, and it will be again yes, which means the answer is correct, it is fine. But if it is not, at any stage we need to rewrite the question. So here we have a question rewriter. Okay, you are a question rewriter that converts an input question into a better version that is optimized for vector store retrieval, because in vector store retrieval, instead of being blunt, if you have some better words in there, it will be even more better to get a retrieval. So here we are saying, okay, look at the input and try to understand the semantic meaning and just make another question out of it. And here we are saying just provide the question, not any other content at all, because if you say provide the question, it will start saying like here is an optimized version and all. So for that, to avoid it, you can just add this one line, or you can just put it as new question. Okay, so here you are saying that here is your initial question and formulate an improved question, so it will provide the answer here. Now, like I said, you need a web search tool for which we are using Tavily search. Okay, so that's why I asked you to put Tavily API key in your .env file. Now we are going to use LangGraph, and for graph state it is going to take three things: your question, your generation, your documents. Okay, these are the values which are going to be available at any point of time in your workflow. Okay, so that is your graph state. In your graph flow, the first state would be, or the first node here it is called node, because a graph is made of node and edges. First we'll define the node, then go on to the edges. The first node is retrieve, and the retrieve node will require a question and it will provide documents as output. Okay, so it means in the state we are gonna change two values. One is we are gonna take the question and we are gonna get the output from the retriever. Okay, so once that is done, you are gonna return the documents along with the question, because like I said, you need to persist all the values. Okay, so once your retrieval is done, you'll grade those documents, right? So for that, you have a grade documents node. What it will do is, for document grading, you need your question and documents, so that you can check if the document is relevant to the question. So each of the document will compare it with the question by calling the retrieval grader.invoke function, in which we'll be providing the question along with the document for each documents. Okay, and we are seeing if the binary score, okay, and if the grade is yes, then we'll be saying, okay, this is a document which is relevant, so I'm putting it in a new variable filter docs. And if it is not, I'm just continuing it by ignoring the documents. Okay, making sure that only the relevant documents are available in there. So now the documents state is changed from documents to filter documents. Okay, so what if there was a state or a position where there are not a lot of relevant documents? It means you need to transform your query, like I said, rewrite your query. So for rewriting your query, you will require your question. So here you are taking the question rewriter.invoke and you're changing the question with a better question. So why are we providing documents? So that you can restart the pipeline. Okay, now since everything is done, let's say your documents is ready, it means you need to go for generation. Okay, so for generation we have RAG chain, and for generation you need your question as well as your context, which is your documents here. So we are going to take two values out of the state and we are invoking our RAG chain. But here we are going to get the output from LLM, which is the generation, and that is the third value of our state. So now you are in your generate node. The next step is you need to know, like if you want to route question, those are all edges. Okay, but there is another node, which is what if the document is not relevant. You need to go for searching over the web. So for that we have a web search node, in which we'll take the question, we'll take the tool and invoke the question, and that will provide our documents. Okay, and here we are combining all the document contents with just /n separator, and we are making that as our document. Okay, so once that is done, your documents are ready and it will combine and start with the same flow. Okay, instead of vector store search, the generate will complete from web search. Okay, now you have your route question node h. Okay, now you have all your nodes. Now you need to see if you want to go for web search or retrieve node. Okay, there are two nodes already available. So for that, what you're going to do is you're going to call your router on your question alone, and here we won't return the state values and all, because it is edges, right? You need to see which node you want to go, and we are saying, okay, if the data source is web search, then you go for web search, or if it is vector store, then go for vector store. Okay, so that is what is already here. Okay, so now we are going to see if it is ready for generating an answer, or should we regenerate a question, which is nothing but grading your documents. Okay, so here if the filtered documents, there is not even a single document which is filtered. Okay, which means none of the documents are relevant. What you're going to do is you are going to change the query so that you can get a better output. But if there is even a single document, we are going to go for generation, because it is not always that, for example, you give 10 documents. In 10 documents your answer is going to be available. Okay, so that is why we have a separate edge for that. Now we are going to see if the generation is grounded in the document and answer the question, which is nothing but your hallucination grader, because once you go for generate, the next step is to grade for hallucination. Okay, so for that, here you have your hallucination grader invoked with documents and generation. Okay, and here if it is yes, we'll be grading the answer as well. And if that is also yes, it means the answer is useful. And why we are returning it as useful is because useful is like a pointer to end state. Okay, it will end your state, and if it is not useful, it will retry. Okay, so that is why we have both hallucination grader and answer grader here, or those kind of edges. Okay, here you are creating your nodes and edges to form a graph. Okay, the nodes are web search, retrieve, grade documents, generate, transform, query, all of those. The entry point is route question, and that is also a conditional entry point, because you're going to see, are you going to go to web search or retrieve node, which do you want to go. Okay, now we are going to add an edge from web search to generate, because like I said, what if you are in a web search, which means your documents are already obtained, then you're going to go for generate function. Okay, but if you're going for retrieve, you need to grade your documents, and once you are doing that, in grade documents you are going to add a conditional edge whether you want to generate or not, because there, like I said, if all the documents are not relevant, then we are going to do transform query. So all it does is, for example, if the value is here, it will be assigned to this node. Okay, sorry, this value will be assigned to this node. So if the grading documents returns a value like, for example, transform query, the transform query node will be the next node. So if it is generate will be next node. Okay, so if it is transform query, then you'll go to the retrieve node again, because you are transformed your query, you need to retrieve the relevant documents again. But if it is generation, we'll go for grading the answer as well as your hallucination and all, because we need to see if it is grounded as well as the answer is right, which means either there is a problem in your LLM output, which is shown by hallucination, or there is a problem in your retrieve documents itself, and we are going to handle all of those. Okay, not supported means the answer is wrong. Okay, here we are going to call the generate for asking the LLM to generate the answer again. Like I said, if it is useful, we'll end everything. Okay, and if it is not useful, which means your documents are again problematic, you are going to call the transform query. Now this is your workflow. Okay, if you call the workflow.compile, it will create an application or workflow code, and when I ask what are the players, what player at the peers expected to draft first in the 2024 NFL draft, here you can see it first went into web search, it went into generate, it checked for hallucination, it made a decision that the generation is ground in the documents, and also it answers the question. So here it says Caleb Williams is the first pick, will be the first pick. It searched over internet, but when I asked about types of agent memory, it said, okay, I'm gonna retrieve. Okay, now the node retrieve, it went into node retrieve and it checked, so if the documents is relevant or not. 4 documents were retrieved and 4 were relevant, and it graded no, all the documents are completed. Now it said, okay, I'm gonna go for generation, and in grading documents it is now completed. Okay, in generation it said for it generated answer. It checked for hallucination. It made a decision that okay, it is grounded in document. It also answered my question, and finally here is the answer. In the context of LLM powered autonomous agents, there are three types of memory: sensory memory for learning, embedding a representation of raw input; short-term memory for in-context learning; and long-term memory for external vector store as retrieval. And that is how you'll make an autonomous RAG agent, which is adaptive for any situation.
I'm going to show you all about an interesting concept which is corrective RAG. A RAG application which can give a feedback to itself and then change the pipeline accordingly. So for this, instead of LangChain, we'll be using another interesting framework which is LangGraph, where we'll be more focused on creating a graph kind of a structure rather than a chain. And the advantages are so much that you can control each and every bit of your pipeline. So that's about the introduction of this video, where we are going to build a RAG pipeline which can give feedbacks to itself and make decisions accordingly based on the rules we provide to it rather than taking it autonomously. Here is a flowchart of how this corrective RAG occurs. Once we provide a question, it will go to a node which is the retrieval node. The node is nothing but a process, and edge is the flow, right? The arrow mark is a edge and the circle is a node, if you want to put that way. Okay, the graph is constructed with nodes and edges, and I'm not going to take a separate class on LangGraph now. I'm planning a big course for that. We'll see about that in a separate video, but right now all you need to know is about three separate concepts. One is node, which is the circle, and then this arrow mark, which is the edge, and then the state, what state it is in. Okay, what all it has. For example, question and documents are there in the state. Question, documents, and generation are there in the state. Okay, these are the three things which are important to know about when you are using LangGraph. Here we have the first component, which is retrieve node. In the retrieval node, all you will do is retrieve the documents, where you will have the questions and documents in your state now, which you are passing on to grade documents. So what happens in this grade documents is, in this node, the LLM will try to find if the documents are really relevant or not by itself. And if it is relevant, what it will do is, actually the thing is opposite. Any doc which is not relevant, if there is one document also not relevant, what it will do is, it will try to go into a node known as transform query. So if you have a query, it will just change the question into another question, and then it will go to another node, which is web search node. Okay, so that it can search over the internet and augment your pipeline information. Okay, and if it is like, okay, all the nodes are relevant, then it will go into the generation node and answer the question accordingly. Okay, so this is how the graph would be like. Okay, and I'll also show you how the real graph is there once we construct it. Okay, here all you need to do is know is there is a conditional edge here, decide to generate. Here you will check if any of the node is not relevant, then only we will go on to transform query. If all the nodes are relevant, all the docs are relevant rather, we'll go on to the generation node directly. Okay, so that is how a conditional RAG would be. Okay, you can also send some feedback here. Let's say if you transform your query, right, you can send it to the node state, retrieve state again, and then you can retrieve it if you don't want to do this web search. Okay, all things are possible with LangGraph. All right, that's why they say like, but it is also possible to do time travel with LangGraph, because with LangChain you don't have a control of what is going on in behind, but with LangGraph you can go to any state you want. For example, if I want to transform this query and then send it again to the retrieve node and then again continue the pipeline, still you can do that. Okay, so if you want to know how to use LangGraph, let me know. I'll make a detailed course on that. And here is a algorithm for the conditional RAG. All it will require is an evaluator, a query rewriter, and a generator. which we'll create. Okay, the input would be your input question and then the retrieved documents whatever you have, and then output would be the generated response. Here what it will do is first it will compute the accuracy for each pair, each document and the question pair, and it will say, okay, is it correct or is it incorrect or is it ambiguous. For this video I've just taken correct or incorrect, but you can also consider ambiguous. Okay, if it is correct, then we'll just use the internal knowledge, okay, which is the document alone. If it is incorrect, we'll just use the external knowledge by going on to web search node. Okay, and if it is ambiguous, what we'll do is we'll take the internal knowledge and we'll also do web search and get the external knowledge, and then we'll add those both. Okay, here K is your knowledge, which will become the context for the model input, and then you will provide that to your generator. Okay, the generator input would be K and X. Okay, here you can see, right, the document is not the input for generator, K is the input. So all you need to do is check if both are relevant, and if it is relevant, just give that document. If it is not relevant, get a web search for that, and if it is kind of relevant or kind of not relevant, consider that along with the web search web search output, and then get that output. Okay, so that's how the WebRAG algorithm is, and now we are going to see about the code. Before going on to the code in detail, let me show you the graph which we are building here. Here you can see the same algorithms here. We are starting the graph passed on to retrieve node. Here is the conditional node, which is grade documents, which has two conditional edges. One is if some of the documents are not relevant, it will go to transform query, do a web search node, and then go on to generate. If all of those are relevant, it will go to generate, and the generated output will be the end. Okay, this is the node or the graph which we'll construct. Okay, but like I said, there are some components which we need to create. Okay, here are my environment variables. First, you need to get an environment variable for Travely and then for Groq. For both of those, you will get your API keys. All right. Along with that, I also have my Langsmith API key. All right, because we need to see some tracings and all. Here, if you see, I'm setting all of those with my environment variables, where here I'm setting Travely API key, I'm setting my Groq API key, also my LangChain API key. Along with that, I'm also setting, okay, my LangChain endpoint is this one, and then my LangChain tracing is enabled. Okay, the first thing we would need is the vector store. So for this, I'm just taking this same blog which we used in one of our previous video, which is about agents from Lillian Weng. We are loading it with a web-based loader, which will use Beautiful Soup, right? So once you load your document, it will split the document at the chunk size of 500 and the chunk overlapping of 100. Okay, so for this, I'm using Olama for embeddings. By the way, this is a completely local corrective RAG. I'm not using OpenAI or any paid APIs. Okay, I'm using Groq, but still you can replace that with Olama if you wanted to. Okay, so here I'm splitting the documents. I'm getting my embeddings, which my Olama embeddings using the model nomic embed text, which is fast and pretty accurate. For vector store, I'm using my face vector store where I'm passing the documents along with my embeddings. And my retriever is set here where I'm setting my search keyword arguments to be 3. I'll retrieve 3 top documents. Okay, my vector store is now ready. Now we are going on to the components. The first component is retrieval grader. Okay, so for all of those, I'm using Llama 370 billion in Groq. Okay, setting my temperature is 0, where I'm saying in the prompt template that you are a grader assessing relevance of a retrieved document to a user question. We are providing the document and user question. If the document contains keyword to the questions, grade it as relevant. If the document if does not need to be a stringent test, the goal is to filter out erroneous retrievals. Give a binary score, yes or no, to indicate whether the document is relevant or to the question or not. Provide a binary score as JSON with a single key score as no preamble or explanation. So what it will do is it will try to see if there is some keywords in there, or if it is relevant, it will say relevant. Okay. If it is not, it will be irrelevant. But we need only a binary score so that we can make that condition check. So we are asking, okay, just give it as yes or no, whether if the document is relevant or not. And we are asking a JSON output so that it will be able to pass easily with a key score. And I'm saying, okay, there is no room for explanation, only I need the output. Okay. Here we are creating a retrieval graded chain where you are providing the prompt to the LLM, and then you are passing it into a JSON output parser, because we need a JSON output. The question is, tell me about agent memory, and we are getting the relevant documents, and we are seeing what are the like we are getting the first output alone. Okay, because we'll have only one output, and then the first output would be the score. Okay, we are getting that. All right. And then we are seeing, okay, retrieval grader, if it is relevant or not. Okay. Here what we'll do is, there are three documents which we are going to retrieve. The first document alone we are just passing to see if it is working, and it is saying score is yes, so it is fine. Okay. Now the retrieval grader is working. Now we need the answerer or the generator. Okay, the generator. Here we are pulling up a RAG prompt from the LangChain hub. All right. Here all we are doing is we are providing the prompt, formatting the docs and all, and then we are providing it to the LLM, and then we are getting the output. Okay. Here if you see, again we are giving the input and we are getting the output. It is fine. There is an important component which we require, which is the question rewriter. Okay. Here we are saying you are a question rewriter that converts an input question to a better version that is optimized for vector store retrieval. Look at the initial and formulate an improved better question. Okay. Here is the initial question, improved question with no preamble. We are always saying we need only the output, no need for any other kind of explanation and all. So here we are asking the rewritten question, and it is saying, okay, what is the agent memory and how does it work in artificial intelligence? And that's cool. Okay, this is what kind of things we need. And then now we need another component, not just this generator, question rewriter, and retrieval grader. Yes, on LLM side we need this, but to search over the internet we need the web search tool. So for that we are creating a Travely search API with Travely search results k is equal to 3, which will search top 3 relevant results. Okay, so let me run all of these. It will take some time, obviously. So now we are ready with a vector store, a retrieval grader, a generator, our question rewriter, our web search tool. Everything is ready. Every component is ready for our graph. Okay. If you see the graph has retrieval, grade documents, generator, query rewriter, and the web search. Everything is ready. Right? Which means we are ready to create our graph. Okay. Like I said, we need a graph state. Graph state is nothing but which is something which will hold all the input or whatever information you have at that state. Okay. So you have your question, generation, web search, and documents. Everything are there in the graph state. So we'll run that. Next, we have all of these nodes as functions. Okay. So first node we saw is retrieve. So we are getting the question from the state. Okay. Here we have question, generation, web search, and documents, right? We are getting the question and we are getting the relevant documents. Okay. So what we are retrieving is we are providing the documents and question. So what it will do is it will change this state. Okay. Here the documents will be changed and the question will be also there. Okay. So make sure that at any time if you call a function, you will provide the input along with that. Okay. Because the state needs to be updated. Here if you see these are all the nodes and the state will be created here. Okay. We'll go on to that later. First we'll see the nodes alone. All right. So next we have the generate state, where assuming that you have the correct documents, the quest and the question, you'll have your RAG chain, which is the generator, invoked with the documents and the question. So for that, we are taking the question and documents from the state, and we are providing the output as well. Okay, the documents, the question, and then the generation. All of these three are provided along with web search if it is needed only. Here, to grade the documents, again, we need the question and documents, right? Because we'll check if the question is relevant to the document, and that is what is required by the grader as well. Here you can see the question and documents are required. So what we are doing is we are getting the list of documents along with the question, and we are going on to the retrieval grader where we are going through the documents first, and we are getting the score. If the score is yes, we'll append it to the filtered documents. And if it is no, we'll set the web search to yes for that document. Okay, we'll set the web search for as yes, and then we'll move on. Okay, we'll not append the document. Now we'll send the documents question along with the web search, because we'll check, right, if it is yes or no. If it is no, no problem, we'll go on to generation. But if it is yes, we need to go on to transform query. Okay, we'll just check if it is yes, and if it is yes only, we'll go on to this transform query. Okay, we'll get the state, we'll get the documents as well, because we need to change the document state. So just to be clear, guys, if you want to change a state, which means, for example, if you want to change the list of documents, you need to pass that as input. You need to have that there, okay, so that you can change that. Here we are passing the question rewriter, and we are invoking the question where we are providing the question, okay, and it rewrites the question. And here now we are providing the documents and better question. Probably you might not need there, but like I said, you need to transfer it from one place to another, right? So you need to return that as well. So that is something you need to have in your mind, okay? While web search, you'll call the web search tool with a query, okay, and you'll get all the results, and you'll create that as a document, and you'll append those in your documents. Okay, you already have a set of documents, and you're providing these documents again with that. Okay, like I said, you'll add those. Okay, you'll not just say okay web search alone. So that's what is happening here. So you know about each of the state right now. And finally, we have, do we want to generate? Okay, we'll get the question, web search, and we filter documents. If the web search is yes, we'll return the transform query. So what it will do is it will go and call the transform query function. And if it is not, we'll call the generate. Okay, that is all. Now your nodes are ready. Your nodes are the first part of the graph. Now you need to create the edges. Okay, so for that, what you need to do is first from lang graph in .graph, you'll import the end, which will say, okay, this is the end, and then the state graph. Okay, the state graph is to hold the state, and here it will take the graph state class. Okay, here we have the graph state, right? Here you can see, right, we have the graph state. We'll run that. Along with that, we'll also run our nodes. Okay, these are our nodes. I'll have these. Just give me a minute. Graph state, nodes. We have our nodes here. And then we are building our graph here. Okay. First node is the retrieval node, and we are adding retrieve. When you are adding node, it means you are adding an edge also here. Okay. We'll add those. First, we are adding the node to the graph, and then we'll add the edge. Here and then we are adding the graph grade documents node, the generate node, transform query node, and web search node. Okay. All of these nodes are given names, and this is what is the name you need to use here. For example, transform query, it will have the same name here. Okay. That is when it will be able to go to that node when you give some time travel thing, like I said. Here the entry point, which is the start point, is with retrieval. Okay, here you can see, right, the entry point is with retrieve. Okay, and then we are adding an edge between retrieve and grade documents, which is added here. And then we are adding a conditional edge. Okay, the edge name is decide grade documents. And what is the edge is that we are gonna do decide to generate. You will not provide that as a node here. Okay, decide to generate is not a node, it is just a function. Right here you can see this is under the edges. Okay, this is not under the nodes here. So what it will do is it will be assuming that, okay, do I want to transform query or do I want to generate? Okay, so here it will just add the conditional edge and it will see, okay, if it is transform query, it will go to transform query, and if it is generate, it will go to generate. Okay, so that is what will happen here. So we are connecting the transform query with web search node to generate, and transform query also, and also the web search node to generate. Okay, so that is how it is connected, and grade documents also will be directly connected to the edge, and that is the final edge, right? Generate, and that will become our end. Okay, make sure that you provide in, or else the graph won't stop. So you need to compile this graph. So we'll do that. We'll also do this. Okay, and if I ask this question, what are the types of agent memory? Now, not use this. It is trying to retrieve, and then here you can see it saw, okay, all these documents are relevant, and then I'm going on to the grade documents. It goes, okay, I need to go to generate, then I'm going to generate. Here it's saying the types of agent memory are short sensory memory, short-term memory, working memory, and so on and so forth. Okay, I didn't call any web search node here. But if I give a question, let's say like, tell me about something like direct preference optimization method, which I'm sure it's not there in the blog. Okay, if I run this, now it will go, okay, I need to retrieve. The documents are not relevant, which means all documents are not relevant to question, not just any. All documents are not relevant, which means I'll go on to the transform query and then web search node. It gone to the web search node, and then it gone to a generate. Direct preference optimization is a method that recasts the alignment formulation as a simple loss function that can be optimized directly on a data set of preferences, and so on and so forth. It gives an answer. It goes for the web search. All right. And that's why I say this is awesome, right? You can control what you want to do. If you want to just avoid this web search node, go to transform query and add the edge instead of web search node to retrieve, right? It will again continue from there, right? If you want to do that like time travel thing, let me know. I'll make a video on the time travel kind of rag. Okay, but this is why I like LangGraph, and I'm exploring LangGraph for some time now. So if you all like this video, let me know. And if you want more videos on LangGraph, for that also let me know. I'll make a course, and then what are all things you can do, some advancements with LangGraph. All right. So yeah, guys, I hope you all like this video. If you all like this video, please hit the like button, share it with your friends. And by the way, I forgot to show one thing, which is the Langsmith trace. We'll go on to that. And I'm not sure in which project it went. Let's see that as well. Which is the most recent one? I think it went to the default, I guess. Yeah, here you can see, right? See, LangGraph. It went to retrieve, it went to the grade documents, then it went to chat Groq, it went to the JSON output parser, and then it went to the chat Groq again. Okay, and here you can see the output and the input as well. So finally, if you see, the chat Groq output was this one. Like this, you can monitor whatever you want with Langsmith, and you can provide a project name and also monitor that. But like I said, it is awesome. So you can also add that Langsmith for your monitoring purposes. I always talk about production in my previous videos. I've made a lot of RAG in production videos, but there is one thing I didn't cover a lot, which is your monitoring. Because as much as we provide importance to the LLM itself to be scaled, it is also very important that you monitor your architecture. And it is not always that you will get a simple task. If it is a general RAG, it's fine. Alright? But if you have a complex task for you to solve, it is not always that your LLM will be giving a good output to start with, because it is a complex task to achieve. We are going to solve both of these issues in this video, where I'm going to show you all how you can create your own planner agent. Yes, it is like the planner agent in Devin. It will be able to make a step-by-step plan to solve a task, and then it will execute the task. And then we'll be also monitoring this agent with the help of one of the best monitoring tools available over the market right now, which is AgentOPS. The dashboard which you are seeing right now in my screen is of AgentOPS. Why I said this is good is the way they have created this application for production level architectures. It's not that they have just focused on simple things like how many tokens, what is the average token. It's not just that. They are focused on how many error types are obtained, what is the session cost on an average, how many errors are occurred at a given specific time, how the session has ended, and so on and so forth, which we will see in detail. All right, there are lots of things which are provided in AgentOPS, and we'll see how you can use that when you're working with production. Now, as a first step, what we are going to do is we are going to see how you can create your own planner agent, so that it will be able to solve any complex task you provide by making a step-by-step plan for it to solve, like how Devin does. It is not going to be exactly a Devin, but this can be as good as that once you upgrade this planner agent with different architectures. Now let's see in VS Code about this task. Here is a diagram on how a planner agent works. So the idea is that you need to create a plan, and then you'll be executing the plan, right? So once your user provides a request, your LLM will first make a plan, and then it will generate a task list. All right. So what we'll do is we'll provide those tasks to an agent which will be executing those tasks, and it will be in a loop with all the tools provided, so that it will try to solve the task which it is given with. So for example, if I say I need to find the best route to, let's say, Bangalore from Chennai. Okay, you just need not see the time, you should see the availability of tickets, you should see the availability of other modes of transportation which could be cheaper. There are lots of things to consider while you are planning for your travel. So a travel planning agent is a great example when you go on to plan and execute kind of an agent. All right, so here we'll be providing that to the single task agent, where the idea is that it will be only running a single task. Okay, so once it does its single task, it will update the state we have with its result, and then what we will do is we'll see if we need to replan to get a better result. If we need to replan, we'll again generate a task list, we'll execute this task, and this will be a loop. And when this replanner thinks that this is a very good result, it will send the output to the user. So now you'll respond the same to your user, and finally your complex task will be completed by executing it in a step-by-step approach. So for this, we'll be using LangGraph as our framework, because it is easier to create an AI agent, a complex AI agent like this, with the help of LangGraph. So we'll be using LangGraph, and also for monitoring, like I said, we'll be using AgentOPS. All right. So I have also given with some explanation here. Thanks to LangGraph for being an inspiration for this video. So the explanations are here, so you can also go through those once you see the video again. So for this, we need 3 API keys. One is Tavily, another one is Groq, another one is AgentOPS. Tavily and Groq, I hope you all know already on how to get an API key from there. For AgentOPS, let me show you now. So here in AgentOPS, if you go to projects, you can just click new project or give a name something like production planner. And guys, people are just thinking if you use API it is not production. Actually, there are lots of companies which I know that are using this kind of an architecture, which is API keys, because you see those are cheaper than something which you can't afford actually, which is nothing but your servers are harder to afford, so they tend to go for API keys. And Groq is one which I suggest, because in production the most important thing is the speed, and Groq supports even custom model when you go for enterprise options. And if you are a simple SaaS startup, then you can still go for cheap options, which is the direct models, and I think those are one of the cheapest in the market right now, so I would suggest the same as well. Okay, so still, if you have any doubts of why I say production with Groq, let me know. I'll make a separate video on why I say that Groq is in production. Okay, so here in your .env file, provide your API keys, which is Tavily, Groq, and AgentOPS. Okay, and make sure that you load all of those here. All right, so let me load it here. And for planner, I'm gonna give production planner agent. Okay, here if you see in LangChain callback handler, they have a callback handler known as AgentOPS LangChain callback handler. Okay, and you can initialize your AgentOPS by calling the init function with your API key, and then what you will do is you'll call the callback handler with your API key along with a tag. Okay, I'm running that as well now, so it will now create an AgentOPS handler. Now you have an option to use tools. Here you have Tavily search results. Okay, because I'm gonna use this in production, and my task is that it should be able to answer any questions it has been asked to. Okay, and it is not always that the LLM will know what it needs to do, so here we are using a tool like Tavily to get the top 3 results. And here it is very important that to monitor the tool usage, right, you should add the callbacks of the tool with the AgentOPS handler which you created before. Okay, so that is very important here. All right, now you have agent executor. Okay, so agent executor is nothing but this is your execution agent which we talked about before. Once it is given a task, it will be able to execute that task. Okay, so for this we'll be pulling up the React agent executor prompt. So this is actually a React style agent which is reasoning and that. Okay, so we'll be using that only. And here if you see, this is how the prompt will look like. Simple. Okay, system message, you're a helpful assistant, and then we'll say these are your messages. Okay, this is nothing very complex. So here you'll call the create react agent, where this is your prompt and your LLMs and tools are provided. Tools is nothing but your Tavily search tool. Alright, so once you provide these, your agent executor is ready. And recently I asked it what are the teams qualified for the semis. So what I'm gonna do is I'm gonna run this again and I'm gonna ask who won. Oh, okay, I didn't execute the tool, so now it will work. And here I should ask who won in the recent men's T20 World Cup. So let's see what it says. According to the search results, India won the recent men's World Cup. Okay, alright, so here you can see it made a call with asking recent men's T20 World Cup, and it gave an answer somewhere from CNN.com, and it finally said me, okay, India won the World Cup. That is fine. Okay, if I asked who's the man of the match, I don't know if it will answer, which we'll see if it can answer with the help of the planner agent. All right, okay, now here we are going to start to build the planner agent, for which you will first create a state. A state is nothing but it will say what is the state we are in currently, and also it will have all the inputs which are required for a state. Okay, for any next step, whatever is required, it will be there. For example, your input, what are your plans, what are the steps completed, and what is the response. All of these are there in plan execute state. Okay, let's run this. And in your planning step, you will first create a base model. Okay, base model is nothing but it will be about your data class kind of thing. Okay, so here the plan class will have only one parameter, which is steps. What are the steps to be followed, which should be in an order. Okay, now what we are going to do is we are going to use a prompt here. For the given objective, come up with a step-by-step plan. This plan should involve individual tasks that, if executed correctly, will yield the correct answer. Do not add any superfluous steps so that like it is not very complex and all. And the result of the final step should be the answer. Make sure that each step has all the information. Do not skip steps. Okay, this is why we added here this kind of a state, and then it will provide a list of steps which will be having it in the planner class. So here you can see the structured output should follow this plan class. Okay, so for this we are providing the planner prompt. Okay, and here we will be saying our question here. Okay, and this will be filled here, and your LLM is chat Groq with a model llama 370 billion, temperature is 0, and still for the planner agent of handler is called, because we are going to see what happens in each step. So we will be adding the callback handler for everything. Okay, so if I ask this one on who is the key reason of the team winning the recent men's T20 World Cup. This is a harder thing, right? Because it should find technically the man of the match. So identify the team's World Cup winner, analyze the team performance, determine their key reason for their win. Who is the key player? Probably. Okay, now it said, okay, I need to find the recent men's T20 World Cup winner, and then I need to find the key player of the winning team. Alright, so this is good. Now it's not always that you will get your expected result. Okay, so you should be able to replan and then act accordingly. So here you have this. Okay, the response is again a class which will have the response. Act is a class which will have an action, which is a combination of your response and plan. It will say the action you need to perform. Okay, and if you want to respond user, you'll use response, and if you want to plan, you'll use plan, because like I said, you'll replan, right? So if you replan, it means your response is not there. But if you respond to user, you need to respond, right? You need not plan. This is the step. Okay, this place you should decide whether you want to replan or respond to user. That is why we have that state of act. Okay, so here it will decide whether it wants to replan again or respond. Okay, so for this replanner, you have a prompt here. For the given objective, come up with a simple plan, blah 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 blah. Same thing. Your objective was this, your original plan was this, you have done these steps. Update your plan accordingly. If no more steps, then respond with that. Otherwise, fill out the plan. Only add steps to the plan that needs to be done. Do not return previously done steps as part of the plan. So it is just to make sure that all the steps are completed step by step, and if you miss any step, that will be added to the plan with the help of the replanner. Okay, so we'll run this as well. And now you need to create the graph. Okay, since this is production, we'll be running every process asynchronously. Okay, because if it is synchronous, it is gonna wait for each step to complete, and here we are not gonna do that. We'll be running everything asynchronously. Okay, so the first step is execution step. Okay, first function which we are creating is execution step, and then here there is plan step, replan step, and we should decide whether you want to end this by sending it to user or you want to plan it again. Okay, the replan step is your replanner is called here asynchronously, and if it is an action of response, you will send it as response to response rather, and if it is a planning, you'll send it to plan. Okay, So plan step is also the same, where you will provide your input as message to the user, sorry, your agent from the user, and the planner will provide you the plan. Okay, so here is the execute steps, which is nothing but which agent do you want to execute. Okay, so if you have the task, all right, you need to execute the task, right? So for that you have this. Okay, you will get the plan from the state of the plan, and you'll get the task from there, and you'll be executing the task with the help of this function. Okay, so this is how the graph is. These are the graph functions which are required. So to understand better, you are now going to create the workflow. Okay, for the workflow you will first provide a state graph. Okay, what are the states in there? For that we need to provide our state class, which is plan execute, which we have provided here. In this we are adding the node planner, in which you have the plan step, and then we'll be adding the agent for execution, and then replan, so that we'll replan it. We will have an entry point for planner here. All right, so here the edge will be between the planner and agent. Okay, and then agent will replan. Okay, finally you will have a conditional edge, whether you want to replan, and if you don't want to replan, you will go to end. Still this might be confusing, so what we are going to do is we are going to run this function display, which will give you a better idea. You're starting, you're planning, you're sending it to your execution agent, which is nothing but agent here. You'll replan. Okay, this will be continuous upon choice, whether you want to go to agent or do you want to end this process. Okay, now we are going to ask the question we asked there: who is the key player for the team who won the recent men's T20 World Cup? Okay, so here the recursion limit is given so that it can go at least, like at most 50 times or 50 plans to solve the task. Okay, so that is what is the idea. So let us see if it is answering. Identify the recent men's T20 World Cup winner. Identify the key player of the winning team. Okay, so it is saying something. Oh, it is saying England. Why? Probably it gave 2022 link. At least if it says something related to Ben Stokes, I'll be happy. Okay, let it execute. It is giving me some answer, but it is able to plan actually for men's T20 World Cup 2024. Let me add that. I don't even know who is this clever. Is it football then? I'm not sure actually. I'm gonna add men's T20 cricket, men's T20 World Cup. I'm not sure if it is biased towards football actually. So let's see if it is able to find an answer here. The plan is correct. This is how you will find the answer, but let me see if it is able to answer correctly. Yeah, it found India won, so probably someone from India. For some reason, it is saying find the key player of the winning team, Grover Cleveland Alexander. Probably here there is a problem of finding the key player of the winning team. I think it should change. I'm not sure who even this Grover Cleveland Alexander is actually. At least it was saying India is the reason. Is not Trevor Cleveland Alexander. I need more information about the key player. At least I'm happy till that. I know this is not the exact answer, but what if I asked the same to the executor agent? What if I asked it here? The link was correct here, but okay, let me give a hard mathematical problem. What is 3? Okay, let me give a statement like this: I have 3 apples. My father gave me 5. I gave 3 to my mom, and 2 to my sister, 1 to my brother, and 8 1. How much do I have, and what is the total cost of apples, with one apple being $1? Let's see what it is trying to do for this answer. When I asked, it is just stopping it here. So if I ask a question like this: what is 3 added to the added to 5 to the power of 10? It should do 5 to the power of 10 and then add 3. Let's see if it is able to do that. Now Until this is getting done, right, let me show you the dashboard. So this is the dashboard, right? So you have the planner agent here, and here if you see, I asked the question who won the recent World Cup, and whatever calls are made, everything was provided here. For example, this one, who was the key player in the recent one World Cup, the identify the original plan was this one. You have done the steps like this, and you need to update the plan. Everything you can follow here. But the good thing is, you can also see that my LLMs have been like getting a call of around 35, and the tools have been called 15 times. And the event distribution is that the time taken would be around, for example, 1 second for this. But even there is an instance where one sample took 20 seconds to run. Okay, so by this you will be able to see some things there. And then here, we are seeing how many common answer or how many common questions have come. For example, the Alexander came 3 times. Okay, the good thing is you will be able to also see this one, which is your tracing. Okay, you can see the call, which is tool or LLM, and you'll be able to see how much time it took. Everything will be shown at the right. For example, here you can see this is a tool call. It started at 18 minutes 24 seconds, and it ended at 18 minutes 26 seconds, which is 1.91 seconds. And the query was initial apple count. Okay, so yeah, here if you see, it said the answer. Actually, it found the 5 to the power of 10, and it said an answer. So maybe it is right or wrong, but it is able to execute it step by step and add 3 to it. Okay, I know it is wrong, but yeah, it is able to follow your steps. Okay, this is just a starting point. This is a simple LLM. So if you can use OpenAI or Claude, which is the most recent model, you will get a better result than this when you're using it in production. This is a testing video, right? So that is why I'm using Groq and Llama 3. So if you run GPT-4 or Claude 3.5 Sonnet, which is also fast but a bit costlier, you will be very good in your production. Okay, and here you can see the timestamp at what time this logs have completed, the prompt tokens, what is the AgentOPS version I'm using, what is the Python version I'm using, what is the OS, and what are my CPU cores, what is my RAM. Everything is provided here. Not only that, if you go to overview, if you see the cost is here, how many error I have faced, everything will be provided here. Average token over all sessions is 21,000 tokens. Okay, based on this, accordingly you can plan your budget and all. So this is amazing, this dashboard, because if you see, everything is here. Action, tool, LLM, error. See, these are, if it is green, it is going to be LLM, and if it is brownish or something like that, it is going to be tool. Okay, if it is red, it is going to be an error. Okay, so that is the session replay, and this session replay is the most likely thing I have, because at any given instance it will show what is the cost taken, what is the model, what is like the tokens taken for prompt, what is the token taken for completion, what is the start time, what is the end time, what is the completion provided by that, what is the prompt given to it. Everything is provided in this LLM call. Okay, so that helps you in production a lot. So yeah guys, that is how you can create a planning agent and monitor it, so that still this is a production level architecture which you can put in your production, because we are not using any embedding model in your local. So this is going to use only the tools, also your LLMs and API. Even you can replace Tavily with your own search engine, which I showed in one of my previous videos, and that becomes something like less costly. So those are your options here.
We are going to see how you can create the most advanced medical chatbot with the help of an agentic RAG approach. And here is how our agent is going to look like. Given a question, we'll be sending it to a vector store, or we'll be making a fallback to the LLM directly, or a call to the search engine with the help of a router. And based on which you are using, let's say you want to use your search engine, and those documents are obtained from the search engine and are filtered. So even if it is from the vector store, it is going to follow the same. The documents will be filtered, and after that you'll make a generate call to your RAG, and there also will be grading. So what happens is, wherever we are seeing a dotted line, it is like, a conditional edge, because it means that it is gonna happen or not is based on whatever node is before that. But if it is a block line, it means it will surely happen in the pathway. So for example, if to start from start to search engine, or start to vector store, or start to fallback, or all three different calls which all are possible, and everything is optional. But if you retrieve some documents from search engine, you need to filter that, and that is a must step. But you need to generate an answer, right? Why it is not in a loop? Because you see, what we will do is, this generation will happen recursively or in a loop, if you want to put that way. So what we'll do is, once the LLM generates an output, we'll try to grade it, and unless and until the grading says okay, it is useful, we will not end the loop. What it will do is, it will go to the search engine and then it will start the loop again. So similarly, that's why I said this is, a dotted line one. Okay, and unless and until it gives an useful answer, you're not going to end. Only when the LLM provides a useful answer, it will end, which means there is a higher probability of you getting the correct answer than in the usual methods. So in this video, that is what we are going to see about. Now let's start with the code walkthrough. Before moving deep into the video, guys, I would like to ask you all to subscribe to the channel if you haven't subscribed yet. Hit the bell icon so that you will get the notification for these kind of videos, and also like the video if you are like these kind of contents from me, so that it will be an indicator for me on what kind of video you all want. I hope you all have liked or even disliked if you dislike this video, because those are the indicators for me as well as YouTube for recommending you content. With that being said, now let me start with the code. So as usual, you need to set your environment variables. You need to provide your Groq API key, LangChain API key to log it in Langsmith. And I have never shown you how it will look in Langsmith. Okay, but if you go in api.smith.langsmith.com and then you go into your advanced RAG project, you'll be able to see all the logs of whatever project you are trying to run. All right, and also we are going to use Tavily API for web search. Now here are the imports. I've used OS obviously to use OS functions. Okay, and then load.env and find.env, because with find.env I'll be able to find my .env file which has all the environment variables, and the load.env to load that file. And then we have the langchain community dot document loader dot webbase, and from there we are loading the web-based loader, right? So web-based loader is a loader which is used to load HTML pages with the help of Beautiful Soup. And then to chunk the documents loaded, we have recursive character text splitter, which will be able to, which will give you the ability to chunk based on the number of characters. And then for vector store, there is chroma, and for embeddings, you're going to use Hugging Face embeddings, and the LLM is going to be any LLM which is available in ChatGroq, and we are going to use ChatGroq API for that. That's why I said you need to set your Groq API key, and then your search will be used by Tavily. Tavily API will be used for your search, and then prompt template to format the prompt for a given input, different multiple inputs, combining those as a single prompt. For that we need chat prompt template, and then Pydantic v1 to from Pydantic v1 we'll be importing base model and field to provide the data model, and literal to say what are all the possible values, and item getter, string output parser to parse the output of the LLM, and markdown to display markdown. And then runnable parallel is just an empty container which will have a value which can be run through the pipeline of LangChain. And then a message class to indicate that it is a human message and it is a system message. Both of them are here, and system message is AI message. And then you have your item getter again, and warnings. All of these are here. Okay, warnings library is used just to filter the warnings and ignore all of those. And if you do load.env and find.env, it is going to say just true. Okay, now here you have your Groq API key, LangChain API key, Travel API key obtained from your .env file which you loaded here, and all of those are set to your environment variables. For a medical chatbot, here we are going to consider a symptom based chatbot. Okay, so if you ask about a disease symptom, it will be able to say. Okay, so that is the idea. And thanks to a Kaggle user, and I'll provide the link of the user as well in the description. From him I was inspired to make this code. So yeah, with that said, here you can see these are the URLs. One is about malaria, another one is about type 1 diabetes, type 2 diabetes, and migraine. Okay, so for 4 of these diseases there are going to be information in your vector store. Please note this point. Okay, now we are loading all of these documents by calling the loader.load function as docs. You have your recursive character text splitter with the chunk size 500, which means for every 500 characters it will be split, and the chunk overlap is 30, which means a 30 character will be overlapped for every chunk. So first one will be 0 to 530, and the second one will be 470 to 970, something like that. Alright, now you have your split documents function being called, which will just split the documents into chunks. And these chunks will be made as embeddings with the help of Hugging Face embeddings. And here we are just setting show progress equal to true, multiprocess equal to true. Even if you take out all of these, it is going to remain the same. Okay, and for vector store, what we're going to do is we are going to call the from documents function. So what it will do is for all of the documents which we created as chunks, the embeddings will be computed with the help of Hugging Face embeddings and will be stored in the vector store. And the same vector store will act as a retriever, which is nothing but the 10th retriever. When you call the retriever.getRelevantDocuments function, which it will try to retrieve top k relevant documents, and by default it is 3. Okay, and here when I ask symptoms of migraine, the same one is repeated again and again for 3 times. Okay, I hope you all got that. Here you can see the search keyword arguments was k is equal to 3, which means your top k is 3. Right now here, like I said before, we are going to make a choice whether we want to go for search engine or vector store. Okay, so we are creating 2 data models, for one vector store and another one search engine, with a description of what is the data model all about. And here we are providing just the query, and we are saying that it is a string. Okay, and here we are creating a router which is going to decide whether it want to use a vector store or a search engine. All right, and here we are saying you are an expert in routing user queries to either a vector store, search engine, or you can use search engine for all medical queries that are not related to malaria, diabetes, or migraines, and because all of those are contained in vector store. And if it is not at all related to medical, just output not medically related and don't try to use any tool. Okay, now if you see, we didn't use the third handle. Okay, so for example, what if there was a question which is not medically related? It can't use any tool and go forward, right? That is why we had fallback. Right, so when I ask about chest pain, it is going to say true because it is related to medical, so it is going to go for search engine. All right, and here you can see when I asked about chest pain symptoms, the name of the tool which is going to be used is search engine. Okay, so it means the router is working. But like I said, nevertheless, what is your medium of retrieval, whether it is website or vector store, you need to filter your document to see if it is relevant or irrelevant. Mostly your web documents won't be, but with vector store retrieval, there is always a possibility for retrieving irrelevant documents. So for that, we are gonna add a grader which will be able to retrieve only relevant documents. How is that? Once you retrieve documents, this grader, it will try to classify between if it is relevant or irrelevant, based on the context, the words appeared in it, and so on and so forth. Okay, here the grader class will have only one data point or data output which we are expecting it to be, and the literal, which is like the list of possible values, which is relevant and irrelevant. So it is about the relevance score of the document. If it is relevant, just say relevant, and if it is irrelevant, say irrelevant. And here we are just, for if the value is not relevant, return irrelevant, because at some point of time it might, okay, it might give not relevant, and if that happens, we'll return that as well as irrelevant. That is why there is a validator there. All right. So here you have grader system prompt template where we are saying about the task of grading. You are a grader tasked with assessing the relevance of a given context to a query. If the context is relevant to the query, score it as relevant, otherwise give it as irrelevant. Okay. So we are saying, okay, do not actually answer the question, just provide the grade alone without any additional explanation. So it was a clear prompt. Okay. And here we are going to make it as a single prompt based on the user provided context and question, because query is obtained from user and context is retrieved according to the user query. So both of those needs to be combined to the grader system prompt template. Okay. So what will happen is here the grader system prompt template will be added here, and below that there will be value of context and query. That is how the prompt will be. And what we are doing is we are creating a chain where once you provide your context and query, the prompt will be created and it will be sent to the LLM with the structured output. Okay, the structured output is gonna follow your grader, and the method is gonna be JSON mode. I want it as a JSON. All right. So when I ask the retriever to get relevant documents, it is gonna get relevant documents of migraine. When I ask my grader to grade it, it said relevant. It is fine. Okay. But when I said about ulcer, it said irrelevant. Okay. Why is that? Because like I said already, in vector store search, you won't have anything other than migraine, malaria, and what was the other one? I just forgot. Diabetes. Yeah, type 1 and type 2 diabetes. So other than all of these, anything you ask, it is not going to be in your documents. So there is a grade for irrelevant. Isn't that amazing? Because if you see now, you know that you are retrieving something wrong, and anything you do hereafter is going to be wrong again, because you don't have the right context. All right. Now you have your RAG template string, okay, which is nothing but your RAG prompt. You are a helpful assistant, answer the query based on the provided context. The context and query will be provided, and we are creating a prompt template based on the template which is there already here, and that becomes the start of our RAG chain, where it will be provided to the LLM, which is nothing but a chat Groq, and the output will be parsed. So when I ask about what are the symptoms of malaria, which we already know that it is there in the retriever, because when I asked about migraine, it is there as relevant. Okay. And I said it is there for malaria and diabetes, which means it is going to be relevant. Okay. So when I asked about rat chain, it gave me answer. Okay. So you know that this is from the vector store, which means we have taken a correct data source. Okay. Now like I said, it is not always that you'll get health queries. So here we have a fallback assistant where what if for example you are using a hospital chatbot, and it is not always that your chatbot will have symptom diagnosis and all. Okay. So at the time to answer, no, like just be a friendly medical assistant and not go in medical related things, you have fallback. Okay. So here we're saying you are a friendly medical assistant created by NHVA. Do not respond to queries that are not related to health. If a query is not related to health, acknowledge your limitations. Provide concise responses to only medical related queries. Okay. Because like I said, it is not always that you will get medical related queries. You will get non medical related queries, and since you don't have a knowledge, you should just be friendly enough and say like I don't know, or something like that. You just take a step back. Okay. And say like I don't know. So for that only we have this fallback, because it is not there in your field of answering the question. But if you want, you can also add another fallback here to answer general questions. That is also possible. But right now here it is not like that. It is going to be like, okay, it is strictly medical, and if you go outside medical, um, I'll be just saying I don't know, something like that, but in a formal manner. Okay. And the fallback chain is that the chat history will be provided, and you'll be just
answering the query after that. Okay, here we have provided the fallback prompt, and that will be provided to your LLM, and string output parse. So when I said hello, it says here, I'm happy to help with any medical questions or concerns you have. How can I assist you today? Now it becomes like a chatbot, right? To start with. But it is only related to medical. But like I said, again, we are going to grade the answer, right? What if the answer generated is hallucinated by LLM? So that's why we have a hallucination grader, where we are going to ask the LLM whether the generated output is hallucinated or not. Here we are going to say yes if the LLM's response is hallucinated, and no if it is not hallucinated. Okay, so the prompt template goes like this. Your grader assessing whether a response from an LLM is based on the context. If the LLM's response is not based on the context, it is going to be yes, it is hallucination. Okay, otherwise it is going to be no. But here we are just saying, okay, I need only grade as key, and I need a binary value whether yes or no without any explanation. That is when we'll be able to easily parse it. Okay, now we are creating a prompt template, and what we are doing is we are running this input to the hallucination grader prompt. Okay, so runnable parallel is just a container, like I said, and it is used for you to make lambda functions like this and all. It will be very easy, and once you run this through your hallucination grader prompt, which means your system prompt will, or your input will be ready, you will be generating a output with the help of structured output based on the hallucination grader class, which we already created here, and the output mode is going to be JSON. Okay, when I asked about malaria, and here I said based on the context provided, the cell area symptoms of malaria include impaired pack, consciousness, convolutions, because this was something generated by an LLM. Okay, and when I said grade the output, it said yeah, it is not an hallucination because it seems to be related to the documents you have provided me. Okay, I've just avoided the call. Okay, so if you want, you can make a response from the LLM, and also then you can move on to the grading. So this is just hallucination grader. Now to check if the answer is actually related to the query or not, so similarly the same kind of class and prompt and the chain is created, and when I said okay, this is symptoms of malaria, that is what I'm asking, and this is the response, and here you can see symptoms of malaria is the word there, so thus it says yes, the response seems to be correct, right? But like I said, right now we have completed only the vector store path. Okay, and we have also covered the grading part and all, which is going to be same for web search, but we didn't create the web search tool. Okay, so what we are going to do is we are going to take the Tavily search tool, search results tool from LangChain, and we are going to create a tool executor which is already there in LangGraph, which is just to execute tools. And what you need to do is you just need to provide list of tools where all needs to be an instance of the tool class, which is from Hugging Face, sorry, LangChain. And here you need to provide your name of the tool and what is the function it needs to execute. You need to have your function. For example, Tavily search is a function, and similarly there will be other functions. For example, for retriever it is going to be retriever.invoke, which needs to be called. Okay, and then a description of what is the purpose of the tool. Okay, so for example here when I need a vector store, I need to call the retriever.invoke function, and this is useful to search over vector database, and when I need to search over the web, I need to use my search engine tool. Okay, so this is the tool I will require, and the agent state will be query, chat history, generation, and documents, because like I said, this is a medical chatbot, right? So you need chat history, and other than that, others are query, generation, documents are conventional ones. Okay, so the retrieve node is going to be focused on getting the query from the state and calling the retriever.invoke of providing input as query, and it will return you documents. Okay, and since the query is not changed, you might not need to return your query and all, but if you want, you can also add it as query. It will not be a problem. Okay, and the fallback node, like I said, what if there is a no tool call, because the first step starts with the tool call, whether you want to go for a vector search or web search. So if none of these are going to follow, it means we need to directly give it to the LLM. So that's why we have the fallback chain, for which you need to have your query
and as well the chat history, because it is going to be a chatbot, right? It needs to remember some things which has happened before. So in the fallback chain, we'll be invoking with the query as well as chat history, and we'll be changing the value of generation now. Okay, so now you have your fallback. Now after that, you need to have your RAG node, your web search node, because you need to search your web. But before all of these, you need to have your question router, because that is the first one. Like I said, we are going to start with a tool call, right? So once the user gives a query, you'll be invoking your router, okay, question router, which will provide a response, okay. And if there is an error, we'll be just saying that we'll go for fallback, okay. If tool calls is not there in the response, because there needs to be a tool call, and if you're wondering, tool call, everything will be just string, okay. That's why we are just making as tool calls, not in response dot additional keyword arguments, okay. If there is no tool call also, we'll go for LLM fallback, okay. But if there is a value there, okay, we'll be taking the name, and if it is vector store, we'll return it as vector store, because we are going to follow the vector store node path. And if it is a search engine, we'll route it to search engine and follow the search engine path, okay. So what if it is a web search? We'll take the query from the state, and then we'll invoke the tably search function with the query, and the documents will be, what are the documents which are the results of tably search, okay. And now those documents are provided there, right? And for retrieval, like I said, which is vector store, we already saw about that. Now for both of these, there is a common thing, which is filtering, okay. So for filtering, you need two things. One is your query, another one is your documents, okay. So what we are going to do is, we are going to go through all of those documents, and we are going to invoke the grader with the query and each of the document. And if the document is relevant, it will be appended to the filtered docs, and if it is not, we will just ignore it, okay. Now whatever documents are there in this filtered documents, which means only those documents are at least considered relevant by the LLMs, are now considered to be the documents, okay. Previously, for example, 5 documents are retrieved, and LLM considers 3 to be relevant, so only now the documents will have only 3 documents, not all the 5, okay. So now that you've filtered your documents, the next step is to answer based on the document, for which we have the RAG chain, okay, in which you will be invoking with a query as well as documents. And the documents, I just want to remind you that it is gonna be the filtered documents, okay. And now it will provide an answer, which will put it into the generation value, okay. But like I said, it is not just that. We'll be, after once it is generating, right, we'll be seeing we need to grade the hallucination and answer and all. So for that, you'll have all of these three, okay, question, documents, and generation. And for hallucination, which means your response as well as documents are important, not the query, okay. And you'll grade your hallucination, and if the hallucination is no, which means it is not hallucinating, we'll grade the answer, okay. And if the answer is okay, fine, something like that, because there you'll be providing a LLM response for a given question, it will be useful. And if it considers that it is not useful, it will just return not useful, okay. And here finally it will return generate as well, okay. When it will happen, if it is hallucinated, okay. If it is hallucinated, it needs to generate again, right? So that is why. All right, now what we are going to do is, we are going to create the graph based on the nodes and edges which we already have, okay. The nodes are going to be vector store, search engine, okay. And then you have your filter docs, fallback, RAG, okay. All of these are your nodes which will be in your graph. And there are some conditional entry points, okay. Your conditional entry point is gonna start with question router node, okay. Question router node, and this question router node here you can see is a function, okay. This function will execute, that is what it means, all right. Retrieve vector store means retrieve node will execute, something like that. And here, if it is LLM fallback, if it is fallback, LLM fallback will be called vector store. Vector store will be called search engine will be called. So which node it wants to go, that is decided here. And we are going to create edges, which means connection between node. So vector store retrieve documents are filtered, search engine retrieve documents are also filtered. Okay, and here we'll be seeing, if we want to regenerate a question and all. Okay, so for that we have a conditional edge, and next also we have an RAG conditional edge, which will have us to see if we want to generate answer again and again. Okay, so that is based on our hallucination and answer relevance. If it says it is useful, which means you got a useful answer and it's gonna end. If you say it is not useful, then the retrieval is not good, then you need to go for another document in the search engine. And if it is gonna say generate, which means the answer was wrong, we are gonna just call the RAG pipeline RAG node again, and it will generate another answer, and this will be in a loop. Okay, and if it is going to be fallback, which means you can't do anything about that, the response will end that loop. Okay, so here we are just compiling the app, and we can just plot as well. Okay, here you can see the plot. Okay, I showed it in the start of the video as well, where once you start, you can go any of these three parts. If you go to vector store, you'll filter your documents based on, if you want to generate, it will be decided based on if it is relevant. If it is not, again filter documents will be executed. Okay, and then your RAG pipeline will execute, and if it says useful, you'll end. If it is not useful, you'll go for search engine, and those will be filtered again. And there is a possibility for you to directly go to search engine as well based on your route. Okay, and when I asked what are the risk factors of migraine, here you can see it went to vector store. Okay, and it said the chunk 1, chunk 2 or chunk 3 all are relevant, and these are the. But when I asked about hypertension, it went to search engine, and out of 4 chunks, out of 5 chunks, 4 were relevant and 1 is not relevant. Okay, and that is why it is said here some retrieved documents are relevant, hallucination check is also passed, and answer is relevant to the question, and here is your answer. But on top of all of these, like I said, it is going to be a bot and not just an agent. So that is why you have an app here. I'm not going to explain the code because it is just a creation of app, and you're going to invoke it with your query and chat history. Okay, app is nothing but your LangGraph app which you created right now by compiling, and once you provide it will be working fine.
So we are going to see about GraphRAG, but it is not going to be like the common video where I'm going to use the Microsoft GraphRAG and then we are going to see that normal book which is converted into a graph and we can ask some questions. It's not like that. We are going to see how you can build your own knowledge graph with the help of LangChain and Neo4j, and then make an RAG pipeline out of it, which will be an hybrid RAG pipeline where we'll take both vector and some graph related conditions both into the picture, and then we'll retrieve a better result than what you will get with just vector store retrieval. With that being said, now let's start with the video. People have been asking me a lot for me to do in Google Colab itself so that they'll be able to use the same. And here I have this notebook in Google Colab, and you can also use this. Alright, so the first one would be to install whatever requirements you have, which is LangChain community. We are going to use Groq LLM, so there is LangChain Groq, Neo4j, so that you can use the Neo4j database, graph database, Wikipedia to load the Wikipedia data, tick token for tick token encoder, Y-file Jupyter graphs, so that you will be able to display your graphs whichever you construct, and then sentence transformers to load Hugging Face embeddings, which is sentence transformer embedding. Alright, so those are the imports, sorry, your installation, and now you are having your imports. From runnables, you are taking a branch, a lambda function, a pass through, and the parallel. All of these are just empty containers which will be able to or will enable you to create a branch within your graph, which will be storing a container to pass the value. Same will be the case for lambda function, parallel for parallel execution, and pass through to pass through a simple chain. Okay, so those are the runnable imports. Chat prompt template for you to use a prompt template where you can render your values, which we all have done a lot of times, and same goes for prompt template as well, which also does the same thing. Base model and field from Pydantic v1, which is used to define your data class, And then you have tuple, list, and optional imported from typing to say the data type, and AI message and human message from LangChain core messages to say if a thing is a human message or an AI message to indicate that in the pipeline. A string output parser to parse the output of the LLM, OS to do OS function, Neo4j graph to construct a knowledge graph with the help of Neo4j Neo4j database, basically both graph database and vector database. And then you have your Wikipedia loader to load your Wikipedia documents, token text splitter to split the data with the help of tick token. That's why we install tick token. Okay, instead of character level, we'll split it as token level. Okay, and we have Groq imported from LangChain Groq, so that you can run your own Groq LLMs, and this will be, you'll be able to run this as well. Because if it had been Groq and it had been an open AI, you won't be able to execute this, right? So that's why I went for chat Groq. And then you have your LLM graph transformer, which will be able to make cipher query out of normal queries and connect with your graph database. So basically there you will be providing your LLM along with your graph database, and that will create a graph transformer class, right? And then you have a graph database imported from Neo4j, which will help you construct the graph database, and then graph widget to show your graph once you create it. Neo4j vector database to create a vector database in the Neo4j instance itself, and Hugging Face embeddings to create embeddings to store in Neo4j vector database. And then you have remove leucine characters to remove some characters, and then you have the same imports in runnable and all. Okay, now here if you see, we have Google Colab being from Google Colab output and all, so that you will be able to see the widgets actually. Okay, because whatever you see as graph output are widgets, and to be able to see that, you need to run that. Okay, there are two things you need for this. One would be your Groq API key, another one is Neo4j API key. For both of these, all you need to do is just create an account in Neo4j as well as Groq, and then what you need to do is get their API keys. And in Neo4j, if you see, they will have a URI as well. Okay, and you need to copy that and paste here. Okay, I'll put it as your URI. Okay, you need to fill that here. Don't worry about the username, let it be Neo4j, it won't create any issues. Okay, here we are loading some documents, raw documents, which is from Wikipedia. Okay, so for that we are using KL Rahul's Wikipedia page, because at the time of this creation he was in some trending. Okay, I just took his name, and then we are loading those as raw documents and splitting it with the chunk size of 512 and overlap as 24. You can also choose whatever you want. Okay, then what we are doing is we are splitting the documents, and we are taking just the first three. Okay, so that this will be faster. Be the creation of the graph and then testing it. For all of these, this will be very easy. Okay, next what we are doing is we are taking an LLM from ChatGroq with the name Llama 3 8B78192. If you want, you can use 70 billion as well. Or nowadays, even OpenAI has become cheaper, which means if you can afford Groq as a company, if you are going for a company level, I would rather suggest you to take OpenAI rather than Groq. Alright, so that is your LLM, and now you need to make your LLM graph transformer, which will be able to, take your graph documents, your raw documents and convert it to graph documents, and then make a query to it. For everything, you need LLM graph transformer, and that is what we are creating with the instance of ChatGroq. Alright, and now if you see here, we are taking the LLM transformer and converting it to graph documents, and in that graph, where is the graph? If you see, here it is, right? Graph equal to Neo4j graph. An instance of Neo4j graph is already created. Okay, and in that graph we are adding documents where you need to provide your graph documents base entity label to create an entity to all the whatever values are appending, because graph is like entities and relationship only. Okay, so if I say Vasanth YouTuber, it would be like profession. Okay, something like that, and include source as well to true. Alright, so here if you see is a default cipher. Okay, match all the values where there is a mention, and return SRT, source, relationship, and target. Okay, I guess it is that. Here you can see this is the graph which is constructed. Okay, here you can see this is replaced, right? Some replaced value kept wicket. These are all something which is constructed. Okay, here you can see Kannur Lokesh Rahul, namesake Rohan Gavaskar. Why was that? It was because Rohan Gavaskar was the name of the son of Sunil Gavaskar, which his dad apparently misheard as Rahul Gavaskar and named KL Rahul as KL Rahul. Okay, that's why it is coming as namesake. And the inspiration of KL Rahul's father is Sunil Gavaskar. The spouse of KL Rahul is Atiya Shetty. He doesn't have children. For some reason, it is giving K and Lokesh and Rajeshwari. Alright, but the opposite is true. It should have been like this. Alright, it should have been parent. K and Lokesh is the father of Kannur Lokesh Rahul, and Rajeshwari is the parent of, or the mother of, Kannur Lokesh Rahul. Alright. So if I had constructed this with a better model, for example, your OpenAI or Llama 3 70 billion, this would have been even better. But it is a bit costlier. That's why I didn't do that. Okay. Here you can see for some reason there should have been Hardik Pandya, as he is the friend of KL Rahul. That's why his value might have been there, but you can see this is a pretty good graph looking out here, right? And yeah, if you want, you can construct some better graph as well with better LLMs, right? So here for hybrid retrieval, what we'll do is we'll combine a graph search output and a vector search output as well as a keyword search output. Okay, all of these will be combined. Okay, so if there is a keyword, KL Rahul's inspiration, I'll see KL Rahul inspiration if there is someone near it. Okay, so that is a keyword search, KL Rahul inspiration, exact keyword search. And if it is graph search, it is going to be like entity and relationship. Okay, KL Rahul, who is the inspiration of KL Rahul? Inspiration is the relationship, and then there will be a target entity there, and that will be your output. And vector search, we all know how it works already. Okay, so all of these outputs are obtained, and based on that it is provided as context to the LLM, and finally we get our answer. But make sure that you have a very good LLM, because here you can see there were some wrong constructs in the graph because it is a very small LLM. Okay, so if you go for a very bigger LLM, it will be better for your performance. Now I'm creating a Hugging Face embeddings instance with the help of all mini LM, where I'm running it in CPU and I'm not normalizing the embeddings as well. Okay, for this what we are doing is we are creating a Neo4j vector database based on the graph which already is there, and for this we are using the Hugging Face embeddings, and the search type is hybrid like I said, and the node label is document, because in LangChain everything is document, right? So that is document, and the text node property is text. Okay, with the embedding node property again being embedding. How the graph retriever works is, when I ask about, for example, who is Amelia Earhart, it detects the entity, okay, Amelia Earhart, and then what it will do is it will take all the relevant nodes. Okay, and what it will do is it will provide the entity as well as relationship to the other entity. Okay, it will take all of those, create full text index entity if not exists for entity on each id. Okay, so this is the query, the cipher query. I'm not very good with cipher query. I'll soon make a detailed video on cipher query once probably I come out of my break. All right, so yeah, here if you see, we are creating a base model in which we'll take all the person or organization or whatever entities appear in the text. Okay, and we'll provide the prompt stating that the system prompt is you are extracting organization and person entities from the text. Human is use the given format to extract information. All it is about extracting the information. Okay, so when I give where was KL Rahul born dot names, it gave KL Rahul. Okay, now you need to create a full text query. All right, so for that, which is your cipher query, and for that we are gonna use this function where first you will remove leucine characters and then you'll split the input. Okay, what will happen is it is easier to show for me. Like for each word, what it'll do is it will split and do space, or what is this name? I think it's tilde. Okay, tilde 2. This will be added actually for some reason. That is how it works. Okay, and then there is a structured retriever, which is your graph retriever, for which you'll query with this specific cipher query. Okay, where these will be filled. Okay, these all will be filled. The entity, the query, these all will be filled. Okay, where query you will be providing with the generate text full query which we already created. So when I ask where was KL born, what it did was it made KL and then Rahul. So what it did was, what are the possibilities which are there, related to this? There was occurrence of Rohit Sharma, Murli Vijay, Gambhir, MS Dhoni, and Vridhiman Saha kept wicket. Okay, probably it should have been, he kept wicket after Vridhiman Saha. MS Dhoni was the one who presented, his debut cap. Okay, so probably that KL Rahul replaced Rohit Sharma as a captain in some of the early age. Murli Vijay he replaced as opener. For Gautam Gambhir, it should have been some reason. Okay, but yeah, it tried to find the relationship and the target entity along with the source entity. Okay, and to create the retriever, what you will do is you will provide the question which will give you the structured data, and also will make an index search or similarity search, which is your vector search for the given question, okay, which will give you your unstructured data. Finally, what we are doing is we are creating a final document or final combination of data where this is the structured data and this is the unstructured data, like that. Okay, and this is what will be provided to the LLM. Okay, I hope you got that. And now we are defining our RAG chain. Let's start constructing our RAG chain. Alright, so here you can see we have created a retriever, and just to revise, here was the pipeline, and here you can see given a question we already extract some entities which will be provided to the knowledge graph, which will do the graph search, and the unstructured query will be used for vector search, and this part is ready now because here you can see the combined sources was what we did as a final prompt there. Okay, all we need to do is add this to a chain and provide that to the LLM. Okay, so what we are doing is, given we are first creating a prompt template. Okay, given the following question, the follow-up question, rephrase the follow-up question to be a standalone question. Okay, because in if you want, for example, your chat history to be used, right, at sometimes it won't do very good with knowledge graphs. Okay, so if there is a follow-up question, for example, where was KL Rahul born, who is his spouse? Okay, his is not an entity which is gonna be there, so it should be rephrased like who is KL Rahul's spouse, something like that. Okay, so that is why this prompt is there, so that you will have your correct question. Okay, and then you have your chat history formatting function, where what we'll do is we'll just append it to a buffer list, where if it is a human message, because it is a chatbot, if it is a human message, we'll append it to buffer with saying that it is a human message, and if it is AI message, with AI message. Okay, now we are creating a branch where first a lambda function will be executed, where we'll be checking and getting the chat history. Okay, we are getting the chat history, and now what we'll do is we'll format the chat history. Okay, so that is what is happening here. A lambda function is executed, and then for the lambda function we are assigning chat history to be the value with format chat history of chat history. Okay, now you have your chat history. You need to get the question, because like I said, if there is a question which is based on your chat history, you need to format it. So you have your question condensing prompt, which is passed with these values, which will format your question and is provided to the chat Groq, and then finally the output is obtained from the output parser. Okay, and finally you have, if there is no chat history, there is no problem. You'll just have X as your question, because if there is no chat history, then there is not gonna be a condensation issue and all, right? So that is why. Okay, now here you have this. Answer the question only based on the context, which is to say that
based on context answer it. There is just the RAG prompt, okay, and you have your context and question here, and we said okay, use natural language and be concise because it will start explaining blah 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 and so on, so reason that's why I said this answer and so on and so forth. To avoid that, we are just adding this line. Okay, so here we are creating the RAG chain where first runnable parallel is used to execute this retrieval and provided to context, and question, it is just a runnable pass through instance to assign the value of question to question. Okay, and then you have your prompt which is formatted, and then your LLM, and finally your output parser. Okay, when I invoke the question, say like chain dot invoke who is Kel Rahul's inspiration, it said Sunil Gavaskar, as his father Ken Lokesh was a fan of Gavaskar, wanted to train him after Gavaskar's son Rohan, but he mistook the name. Okay, but when I ask when was he born, okay, and the chat history goes like this, right? Who is KL Rahul's inspiration and the answer. Okay, so what I did was I give that a stat history, and here you can see KL Rahul. Okay, when was KL Rahul born? Okay, so it found that okay, its birth date is 18 April 1992. So answer is 18 April 1992. Okay, so that is why I love this hybrid retrieval, because it is fast and it is more accurate than a normal retrieval, considering you have a very good uh, LLM to create the graph, knowledge graph. This is amazing. Microsoft has released the most advanced form of RAG till date, which is GraphRAG. Instead of just using the conventional chunking and followed by retrieval method, this uses a different approach for answering the questions, and the answers are pretty amazing. In this video, we'll see how you can also use GraphRAG to build your own first GraphRAG application. Let's start. So here I have the terminal in which I have already created an execution which was so long. Now I'm going to explain all of those. Unlike me just showing the command, I'm going to explain what happens. Alright. First things is you need an OpenAI API key for this. Without an OpenAI API key, you won't be able to do this. You need an OpenAI API key right now. So that is probably a flip side right now, but I hope soon the community will try to create support for LLMs like LLM APIs like Groq or any other APIs. Alright. First thing is you need to create a GraphRAG project. Okay. So for that you will run python -m graphrag dot index hyphen hyphen init hyphen hyphen root. Okay. So this will create your project. So in that you'll be providing your dot. Okay, so what happens is your input should be in your input folder. Here I'm using a book from Gutenberg live project, which is on Christmas Carol, a book written by the famous author Charles Dickens. Right, so this is a very long book. It is around 3000 lines, right? So it is a pretty long book. We are going to use this as input. Make sure that you have your input as a .txt file or .csv file inside the input folder. Right, now what it will do is it will create your this folder which is output. Okay, when you call this init, right, what happens is you will have a folder known as prompts, as well as this folder. These files will be created, your .env file and settings.yaml file. In your .env file you need to provide your GraphRAG API key, which is your OpenAI API key. Just fill it here. Okay, so once you do your initialization in the root, and if you are having these settings.yaml, here you can see it will take GraphRAG API key, where for embedding it is using text embedding 3 small, and LLM I have changed it to GPT 3.5 Turbo because that is the least costliest. But you would be shocked when I say how much it costed me to create this, right? But it was worth it, I'll say. Okay, so here they are providing API base and API version also. Theoretically, I'm not practically saying it. Theoretically, it should support Groq LLM at all. Probably you can replace your Groq API key here and change this API base to Groq API OpenAI compatible URL. Probably it might work. I'm not sure. Okay, but yeah, that should be an option. But if you want me to try, let me know in the comment section. I'll try and let you know. So that is about your configuration. Okay, so that will be your first step. You're initializing your project here, which is a GraphRAG project with the help of root. Now you need to create your indexes. So for that you will call python -m GraphRAG index -root space dot. You're not initializing it, you're indexing it now. Okay, so that is where your input comes into the picture. You have your .txt file, and that will create your folder like this. This is not needed. Okay, so this folder will be created, which has two folders. One is artifacts, okay, and then another one is reports. In reports you will have all your logs. Okay, whatever is did here, all the logs will be here. If you want to go through, if you have some time, you can go through those. Okay, and here you will also have the indexing engines log. Okay, the engine which indexed, right, which is your OpenAI embedding running engine. Those logs will be here as well, but we don't focus on those. We focus on these files, which is your artifacts files. Okay, in stats.json you have some stats which I don't understand really, to be honest with you, but there are lots of files which you can go through. Unlike just saying okay these are there, we'll be seeing what is happening. Okay, now when I call this, it took me some time. Okay, this is how it created. The first one was it was creating base text units. Okay, if you go into this folder, which is create base text units, let me copy the path. Those are all just Parquet files. Okay, all you need to do is just copy those and paste it in a notebook. Okay, create base hyphen text units, not Parquet. It's running now. Let me show you the df. Here you can see these are your chunks. Okay, you are having an id, a chunk, and your id and chunk id are the same. And then there is the thing called, they have provided a document id. Okay, here the document id is same. Why it is like that? Because you might face some situations where you will face multiple documents. Okay, so that is why it is like that. And then they are creating an entity graph, which I'm not able to see. Okay, probably I'll see if there is a software where I can see the graphml xml file. Okay, so if I found that, I'll show you these. So there are lots of graphs being constructed here. One is base extracted entities, and then they are summarizing those entities, and then an entity graph. Okay, all of these are created. So for all of these, again there will be a Parquet file which will have the XML string, graph ml in the format of XML string. So if you can visualize it, well and good, you can find a graphml viewer and then put your XML file there. Okay, but now we are going to see about the create final entities file. Okay, because if you see, it has 8 columns. Okay, 350 rows and 8 columns, but we need to know what is going on behind so that we can assume what happens. Okay, I'll explain what is happening while it is working, that is later. Okay, but it is very important that you understand at the base on what are the files in here. So if you run create final entities, right here you can see you have an id which should be a chunk id or your name id, and here it is trying to find all the entities in your file, and then it is trying to find the type with a description from where the entity was found. For example, Charles Dickens was found in this description with a person in it. So the same was Arthur Rackham and so on and so forth. And this text unit IDs are where you will be able to find these names. Okay, so for example, Project Gutenberg is something you'll find in these text IDs. Okay, now rather than having just chunks, you have something where this is your entity and these entities are available in these chunks. Okay, that is something you have created right now in create final entities. Okay, and then they'll be creating nodes. Okay, because this is following a graph approach. So for that, again, whatever name is shown here, all you need to do is just replace here, create final nodes. Here you can see now that you have your title here, your type here, the description, the source ID. So source ID is what are the documents which are there here. So community, this is very important actually. I'll say what is community later. Okay, and then you are having an ID for this specific um, description. Okay, so those are the things which is available here. And then the more important thing is you have a top level node ID. Probably I'll make a detailed video on GraphRAG very soon, because there are lots of columns I need to explain about, and I also need to explore in detail about a lot of those. We'll see about this later. Okay, here those are your nodes. Okay, but we need to focus on communities, because this GraphRAG runs two different types of searches. One is local search and another one is global search. Okay, so here you can see these are the communities. Okay, there is community 5, which is its number, which has all of these relationships, entity relationships inside that, and this will have all these chunks inside it. Okay, so they are trying to build kind of clusters inside a document. So for example, these all should be related together based on these topics. Something like that is what they are trying to construct, so that you won't lose a context, which is something very usual with a conventional RAG. Okay, so similarly there are some other files as well. For example, final relationships. I'm not going to show all other files, so we'll be seeing this file alone, create final community reports. Okay, so if I run this, here you can see this is the most important file actually. This is going to be your for example, your phrase vector store which we create, right? This is what it uses. So this has all the content which is there for the community 39, and then a title for it, a summary for it, a rank explanation for it, what are the findings which led to making this community, and then a community ID for those. Everything is provided here. Okay, but we focus more on the community created, which is nothing but a group of chunks which has some relation to it with each other with a context. So for example, here the first community is about explaining the Ghost and Scrooge's Christmas journey. The second one is Scrooge's transformative journey with spirits. The third one is about Scrooge and Christmas spirits, and then transformation, and so on and so forth. Okay, so yeah, that is how the file is constructed. And now, like I said, there are two different searches. Okay, the one is local search, another one is global search. Now you have your global search. Global search is a type of search which will happen across communities. Okay, so I'm not going to go in detail, complex and all. Okay, it will go across communities. So for example, you have around 50 communities. Okay, it will happen across 50 communities. That is how it happens. When I ask to know the moral of the story, you need to know about the whole story, right? So this was its response. The story primarily revolves around the themes of redemption, self-realization, and the transformative power of compassion and empathy. Through the journey, characters like Scrooge and Bob, the narrative emphasizes the importance of embracing the holiday spirit and so on and so forth. It gives a very detailed response, which used these reports, community report number 41. Am I able to find that here? Let me see. 15 is there. Okay, am I able to see 15 here? Oh, for example, yeah, this was used. Scrooge and Christmas spirits is a report used in this. Christmas and Scrooge transformation is used in this. 48, 49. The report numbers which is used is given here. Okay, so those are the references. That is amazing. Okay, it said from where it tried to create this. So like I said, it is happening across communities. So the most important file would be this one. Okay, so make sure that you understand this file, which is create final community reports. Okay, that is how the global search happens. But when you go on to the local search, right, it will not focus on communities, it will rather focus on a single community, more focusing on its entities, and relationships. Okay, so for example, if I find an entity, let's say Scrooge, I'll be finding the relationships of Scrooge. Okay, so is Scrooge a kind person? So that will be in a relationship. So something like that. Okay, it will be like a graph. So first you will find a Scrooge entity, and then you will go on to the relationships the entity has. So for example, Scrooge will have a lot of relationships. Scrooge entity. Those relationships will be seen, and based on that, an answer is provided here. Okay, so local search will be more on a specific entity, and global search will be more across communities. Okay, if you have some specific question, you should go for local search. If you have a more generalized question, you should go for global search. That is the difference between local and global. I hope this should be more detailed understanding rather than just saying local search and global search. Okay, so my initial views of GraphRAG is that it is very amazing. It is good on Microsoft to release this as open source because now you can use that. The only flip side right now is it uses OpenAI, and it took me around $1 actually. Not exactly $1, but to create these much files, around $0.7 I'll say, which is a pretty large thing for me. Hopefully they provide support for Groq or replicate kind of APIs. But yeah, I like this, and I think RAG is now a mile ahead from what it was before. Thanks to Microsoft for that again. GraphRAG is amazing, but it requires OpenAI API key, and that is a disadvantage for a lot of people. What amazing it is gonna be in this video is that hereafter you need not use an OpenAI API key, because in this video I'm gonna show you all how you can use GraphRAG with the help of Groq API key itself, and for embeddings we'll be using LM Studio, because in an RAG pipeline there are two main components. One is retrieval and then generation. For generation you have your LLMs, and for retrieval you have an embedding model which is going to be your vector store. For retrieval we'll be using LM Studio, for which you should install LM Studio. You can download an installer file, and for Groq make sure you have an account. These are the prerequisites for the video. Now let's start with the video. These are the commands. I'll provide the command.txt file probably as a comment in the description. Here, if you see, there is an output which is obtained without the help of OpenAI API key. I don't have an OpenAI API key. If I'm gonna run this question, it will be giving me an answer with the help of Llama 370 billion, which is the LLM I have used in this video. So for this, the first thing would be for you to go on to your LM Studio and download a model like how I'm going to do right now. Once you install LM Studio, you'll have an interface like this where I want you all to search Nomic embed here, which will give you options like this: Nomic embed text v1.5, q2k, q3k, and so on and so forth. Here I used q4 quantization, q40, because that is pretty less in size. But if you have a very less GPU or even no GPU and you want to run CPU, right, I would suggest you all to go to Q2K as well. But these are just for learning purposes, right? So even without OpenAI API key, you should be able to test what is going on behind. That's why I'm saying this. Okay, so you can take this model as well. All you need to do is just click download. Okay, and once you have downloaded it, if you see here at the last, you'll have an option called local server, in which there will be an option here, embedding model settings. Right now I have only the Q40 model, but if you install any other model, you'll have those embedding models here. Just click it and it will take some time to load. Okay, and what I need you all to do is, here there will be an option to start server. Right now the server is running for me, but for you it is not running. Okay, so click start server. I hope you all have done it right now. The thing you need to notice is the OpenAI compatible URL is this one, the localhost 1234/v1. This is a very important URL for us. Okay, just keep this in mind. Now you should go on to your Groq API key. Alright, so let's go on and get our Groq API key. So here you have your Groq API playground in which you need to go to your API keys and just click create API key and just type some value, click submit and copy this API key. Alright, I already have an API key for me, so I won't need an API key, but you need it. Okay, so once these are done, your prerequisite for to start the project is ready. Now let's start with the project. So you'll have your VS Code folder opened. All you need to do is just run these commands which I'm gonna show right now. Okay, you have commands.txt. Like I said, it will be available in your command section. Okay, you'll be executing one by one. First you need to do this one, pip install GraphRAG, which I run, and for me I already have those. Okay, so for me I won't have any problem. So the next one would be for me to create my what you can do is just create it here itself. RAG test. It is not correct. Actually, I think it's my Windows issue. Okay, so what you can do is you can just do this one. You can run everything inside here actually. Okay, and don't worry, it will work, right? So now I'm gonna run the same command. Now you can see, right? That is Windows, probably one of the shittiest OS. Can't do anything about that. So what I'm gonna do is I'm gonna copy this one and I'm gonna paste it here. Okay, this is a book of Charles Dickens. Okay, written by Charles Dickens on Christmas Carol. Okay, I'm gonna shorten this up a lot. Okay, I'll show you once this is shortened. So since we are using local embedding model, it will take a lot of time to encode 3000 lines. So all I did was just cut a lot of content. Still it has a lot of content, 300 lines is there. That is still a big one. Okay, so once that is done, you will start with initialization of your GraphRAG project by running this command. Okay, python -m graphrag dot index hyphen hyphen initialize. The root directory is this directory, so it will take a few minutes and it is done. Okay, now what you need to do is in .env just add another variable known as Groq underscore API key and provide your API key here. Okay, your API key should be provided in this empty string. You should fill it. Okay, so once that is done, go into your settings.yaml. All right, so the first one is change your model to whatever model which was provided in Groq. Okay, so for example, it was Mixtral hyphen 8x 7b hyphen 32768. Okay, so here you need to do a lot of changes actually because of Groq API is free and there are some restrictions. First thing is max token, just change it to 3000, and you need to change the API base. So the API should be OpenAI compatible API. All right, so already we saw the OpenAI compatible API for API URL, which is localhost 1234/v1, which we saw in LM Studio. That is for embeddings. Okay, so similarly there is an OpenAI compatible URL for Groq as well, which is https /api.com/groq api.groq.com/v1. Okay, this is OpenAI compatible URL. Okay, now you need to do a lot of other commands as well. So this one, tokens per minute, requests per minute, probably even retry read be changed. Okay, retries to 3 and tokens per minute to 3000 and requests per minute to 10. Okay, so these changes are very important. That is for your LLM. So here you need to do another thing, which is to change your API key, which is GROQQ underscore API underscore key. Okay, so you need to provide your API key as well here, and then you need to come on to your embedding. So here this is very crucial. Okay, for this model what you need to do is, let me show you. Okay, go into your LM Studio. Okay, if you go into your LM Studio, you are seeing a name here, right? Nomic AI and so on and so forth. From here copy this till here. Okay, copy it and go into your VS Code again. Here in the model name just paste it first. Okay, and remove this resolve and main alone from here, and that is how you need to provide your model name. Okay, for API base, we already saw it is going to be localhost 1234 slash v1. Okay, you can just copy that and paste it here. So what I'm going to do is I'm going to copy that and I'm going to paste it here. Okay, so and other than that, if you want to reduce, right, the chunk size, you can reduce it here. It is 300 tokens and chunk overlap is 100. You can change those. The input file is type is text. There is CSV also allowed, but right now we are focusing on text. Okay, so here we have said that the input directory is going to be input, and then all the files which are under the name .txt is our input. Okay, so these are the configuration which you need to change, and after that you need to run this command, which is your indexing command. Okay, this will index your documents, but the bad thing is, since you are running it in your local, it will take a lot of time. I'll see you after that. It took me around 20 minutes actually. Finally you have your things which is ready here. The similar kind of folder structure what OpenAI produces is already there here. Finally, your document is ready for answering some questions, and here is the command which you should use for asking the question. For example, this is a global search question which I'm asking about what are the top themes in the story, and it should probably say the answer. But the bad part was when I was testing, it didn't work for local search actually, because it gave me some error like there is a zero division error. Probably there is some problem there. I'm not sure. Okay, but yeah, here you can see it is working, right? Global search, top themes in the story, it is working. Okay, and that is how you can run GraphRAG in your system without using OpenAI, just with the help of Groq. So yeah guys, I hope you like this video, because there have been lots of people who have been asking me, Vasanth, you usually don't make videos by using OpenAI because we all are not able to use it, but this time you did. We are not able to use, like that people were asking. So I finally made a video with Groq. So yeah guys, just hit the like button to encourage me, and also it will help people to understand that okay, it is possible to run without using OpenAI as well.